Hi everybody, welcome back to Qt series with C++ and CMake. By the end of the series, you'll be familiar with Qt6 framework, QtQuick, which is mostly used nowadays for real software, and minimum required CMake, so you can make your apps. This episode is an introduction. I will show you how to create an empty project and discuss the project structure. Also, the episode will cover the use of some basic input and output that Qt framework provides us to show info in the console. So let's just dive right in. So here's my Qt creator. I expect you to have Qt creator downloaded. There are tons of videos out there on how to do that, and the installation process is not such a philosophy. So I know that you can do it without my help. As you can see, I already have some projects, don't worry about it. When you first open your editor, you can see so many different buttons, but don't worry, we'll get used to it. Just for now, we want to create a project, so let's click on the Create Project. As you can see here, you have a bunch of options, but we are interested in application Qt and Qt console application. Just for now, we don't want to jump right into QtQuick, and I want you to build a good basement in just a framework. So let's choose it. You can choose whatever location you want and specify the name of your project. Let's say I'll name it tutorial 1. I already have that. So video, but you can choose whatever name you want. You can also set it as default project location where you chose, and go ahead and click next. And here we want to choose CMake as a build system because CMake is mostly widely used nowadays. We skip the translation file because for now we don't want it, and in the kit selector just select all, because you might want to use it in the future. I mean, debug mode is really useful sometimes. Okay, let's hit next. And here in the version control, we also not gonna choose any version control. I mean, any. We have only Git. If you want, you can, but it's the introduction episode, so I won't do it. So let's finish and create our project. After project is successfully created, you can see your main CPP file with the main function. I won't explain very basic stuff about C++, such as what is functions, loops, and variables, because I hope you have some knowledge about this beautiful language. I will mostly focus on Qt framework and what is really happening. At the beginning of main function, you have Qt core application that is used to event loop management, lifecycle, and centralized object management. If you don't really understand what that means, for now, don't worry. We will discuss these topics in the future videos, and I will do my best so you understand it. So here really we just create a variable that manages all application. And here notice some interesting thing. We return a.exec method. What? As you remember, in C++, in most cases, we return 0, just like that, at the end of the main function, if everything is okay, or some status code, if we want to notify about problem. But here we call exec method, and you probably wonder what it even doing. See, Qt framework is mostly used for desktop apps. And every such app needs to have an infinite loop inside, so it can manage timers, events, or other input. Even though we have a console app that should have a start and end, we also need to add it to work with the framework functionality, such as signals and slots, for example, that we will discuss, of course, in future episodes. As you can see, there is also a comment. If you read it, here it says, call a.quit or a.exit to quit the application. And it also gives us example that we will test later, and I will show you how it really works. In the project, as you can see here, we have also cmakelist.txt file. Here we have it. If you are not familiar with CMake, it basically helps us build projects for different compilers and environments by providing simple configurations, calling functions like here, what you see. By series going, we will see how that file changes, but just for now you should know that we can provide some info for Qt with the set function. Like here we can set, for example, language standard or something to relate or something, some another stuff. And add our files with the functions like add executable. There are other functions, and I will show it to you as the series going. I know that you're probably a bit tired of my talking, but trust me, as more carefully you listen, as fewer problems you'll encounter in the future. Not every tutorial will explain you bit by bit what is happening. And now let's go to the main CPP file. And we have very responsible work to do. We have to write a first hello world program and understand what is happening under the hood. When you develop Qt app, you can use standard CPP library. For example, IOStream, like you can write include IOStream. It's not an error or something to print data. But Qt has its own mechanisms, and it is recommended to use it rather than standard C++ libraries. I mean, that is why we call Qt framework, because framework is like container with a bunch of different libraries to make everything you want. Okay. So I started and then deleted. Sorry. Instead of IOStream, we'll include QTextStream. It's something similar, okay, but in Qt. It will give us a way to input and output data in the console. At the beginning, I will show you the harder way to do it, and then the easier one that you'll mostly use in the next episodes. Before we will dive into QtQuick, and you'll display it in your on your interface. The longer way and the harder it depends on the thing that you have to create QTextStream object passing parameter in the constructor. So I won't delete comments for now, and let's see how you can create that object. So as a normal C++, you write the type, then name. Let's firstly make input stream, then output stream. Stream. And here it is important thing that we have to show to show in program that we want to have input stream. Here we write std in. Okay, and then let's copy it and make the same just with the output stream, and it's gonna be std out. The very important thing here is that std_in and std_out don't actually have anything related to the that std namespace that you probably write it earlier, and you write like std, cout, and all of that stuff. It's not have anything related to it. What you pass is just macros. As you can see, if you hover your mouse over, you see it's macro. And that macro is and those macros are representing the pointers to the file structure. I mean, the structure of the type file, like this. And that structure allows you to read and write input. If you, as I say, if you hover your mouse over, you can see it. If you want, you can dive into it, or you can just trust me, but because like how you like. Then, as you created it, you can write something similar to what you made previously. For example, output data, and we can output it. Let's say enter your username. For example, we sign in some console app. Okay. And then what we want to do is read that line that the user want to provide us. And for now, let's quickly include type that we want to use. It's QString. I mean, for now, you can think of QString just as normal string. Of course, we will later discuss it more deeply, but for now, it's just string, okay? Username equals to, and here important thing, but I mean, it's similar to what you done in just C++ with the IOStream. And here's get input stream, read line. If you want, you can specify the maximum length of string that you read, or you can just pass it and read the string that we have from user. And then it's logical that we want to output stream, let's say hello username. Okay. Now, if you try to run your app, let's try. As you see here, application output, and you really get nothing. I mean, even the terminal didn't open it. What is happening? So we have a couple of mistakes, and the first one is that if you work with console and want to see something in console, then we have to configure out our project. Let's go to projects, here run, and check the run in terminal. Okay, then let's go to edit. Let's run it one more time. As you see, the terminal opened, but we don't have that output. There is nothing. Okay, we have one more mistake, and it is more interesting. I am not sure if you remember it from your maybe some C++ tutorials, but every stream in C++ works like a stream and could be broken. So we have to add one interesting line after every output string flush. So after we flush it, we kind of fixed it. And here also we have to add, if you try to run, let's try, as you see it builds. And we have here, enter your username, I don't know, user1, hello user1. Everything works fine and properly, and that is fine. As you see, it took us a bit of time to write output functionality. As I mentioned previously, there is easier and faster way. Instead of flushing and creating objects, Instead of we can use QInfo, or it has another types, for example QDebug, but for now we will use QInfo. What is that? So first things first, we have to include it. I mean, why I could write it? Because I included QString, and it has already that library, but in normal world you have to include QDebug. So okay, let's write it. Let's remove object from our code and then just write like this, and I will explain you why it works. Oh, sorry, I deleted all text and I don't want to write it one more time, so I will just copy and paste. And here it's similar. I don't want to write it one more time, so I will copy and paste. Let's quickly run just to make sure it works, and I will explain you what is happening here. Can make it more beautiful like this. Enter your name, QE, and as you see it very nicely outputs for us. So what is really happening is that QInfo is really macro. It's also macro, as you see. And it returns us just a temporary stream-like object for login. And it makes everything that is necessary instead of us, so you can just output data and don't care about nothing. As I mentioned at the beginning of the episode, we call a.exec method to run application loop. Instead, we can run it for some time and then quit. Let's use the suggestion in the comment section and include QTimer, and then copy and paste, add single shot at the beginning of our function. I won't explain for now what is single shot, but it's like after 5 seconds that function quit will be called. Okay, I will explain it more deeply in the later episodes. Okay, and now I will left all code here. Let's remove comments, we don't want it anymore. And if I run it, okay, let's save all. It builds. Let's wait a second. If I run it, I will wait 5 seconds, okay? I won't enter my username, just wait 5 seconds. I think 5 seconds is gone. Let's write something. No, it was just, it was like 5 seconds, okay. Let's put 1 instead, because I want to show it for you. I'm not patient, as you see. Okay, 1 second is left. If I write something, you see, before I get my second output, I get here that message. Process exited with code 0. So our program like quitted, and then we got our output. And that's how it works. So we can quit program before the end. We'll discuss timer and bunch of interesting stuff in the next episodes, but for now I think it is enough. So thanks you for watching, and don't forget to stay motivated and learn Qt. Hi everybody, in today's episode we are going to discuss probably the most essential topics in the Qt framework, or more precisely QObject class and meta object compiler. So listen carefully and let's dive in. I want to start with a little bit of explaining, and then we'll write an example program in the editor. The first thing I should say about the QObject class is that it is a herd of framework. It means that nearly everything in Qt inherits QObject inside. As you see here, it is the list of classes inherited by QObject. And as you see, it's like huge amount of classes. The standard C++ object model provides very efficient runtime support for the object paradigm. But the thing is, classes that don't have some basement is inflexible in certain problem domains. GUI programming is a domain that requires both runtime efficiency and a high level of flexibility. This central feature with QObject opens us very useful features in Qt to develop GUI systems. Now let me draw a bit and explain the advantages. First and foremost, the advantage is signals and slots. We will discuss it more deeply later, but for now, just think of that as if you have, for example, button, that is button, and I don't know, a mail sender, for example, the thing that sends emails, mail sender. And you want to add some functionality so that when you click button, sender gets something and can send the mail, for example. And that is what signals and slots are actually used for. So when button is clicked, the signal that was previously connected to the slot is emitted. For example, you have here a slot. Let me move it a bit. A slot in the mail sender. Let's put it inside. And here you have signal. And when button is clicked, someone pressed it, click it, then you emitting, I don't want to write it, but you understand, you emitting the signal, and previously, before you emit it, you should connect a slot to the signal. And after emitting, every slot gonna get that signal that you have to make everything that in the slot, because slot is we can say that slot is a method or function that you just write and it later called. Second advantage, and very important one, is that objects organize themselves in object trees. Similarly to signals and slots, we will discuss that more deeply later. But for now, you should understand that all objects, for example, one object, second object, like objects, that's all some objects that is inherited from, of course, QObject. Build the tree, so we can put like parent and child relationships, so that it automatically deletes its children in its destructor, that object. It allows to avoid memory leaks and strongly helps us to solve one of the most problematic parts of C++ language. And for example, here, let's say that object, it can be even your application. It's your app that you creating at the beginning of main function. And you can set, and for example, it's your objects, some objects. And you can set application as a parent to the child objects. So after a program is ended, then everything is deleted for you, and you don't have to write delete this, delete, and you don't want to delete everything, all the three objects. Qt makes everything for you. And one more advantage is that the fact that everything in Qt is QObject gives us a very easy way to cast objects to certain types. And if an object has a different type from the one you want to cast, but inherits the same class, then you actually can do it. And here in documentation we have a wonderful example when you like here, for example, let's assume my widget inherits from QWidget and is declared with the QObject macro. We will discuss what is QObject macro later. And you can create it specifying the type QObject, and then you can cast it to the QWidget, because everything is QObject. And like if you take a look on this example, if you, for example, cast it to the QLabel and it is not the same, for example, the just label is 0. And you have less problems with casting your objects because you have one base class that is called QObject. And now I know I just gave you a huge amount of information, but now let's open the editor and see how it looks like in the code. In this episode, we're going to make a simple task managing console app. It is simple, but you'll be able to see how QObject and core concepts work. By the way, you can find the full code in the GitHub repository, and the link is in the description, of course. As you see, I opened the editor. In the previous episode, I showed you how you can create your project, but now I want to create a separate project for this episode. So let's hit create project the same way as we've done it before, Qt console app. I'll name it the same way, tutorial to video, and use default. Here specify CMake, skip, skip, and skip. And you have your project. As we created our project, let's right click on the name of your project and hit add new. Here we want to choose C++ class, because I want to add C++ class, of course. And it will make us header and source files. So let's name the first class as task. Here in base class, let's choose QObject, and as you see, include QObject and add QObject macro is also checked, as we selected base class. And here let's capitalize header file and source file names. Then hit next and finish. The first thing I should mention is that if you take a look at the cmake.list.txt file, you'll see that names of just added files were added to add executable function. If you, just for the testing purpose, comment those names, files, and you save it, wait a bit, as you see, files won't be added to the final build, and you won't be able to see them in the project structure view in the editor. You see here you have only main CPP. So let's uncomment it, and it should be here. Now let's go to the header file and see what is happening here. The first two lines and the last one have to deal with macro called task_age. If you haven't seen a similar code previously, you're probably confused and don't understand why they added. The thing is that include directives, when you, for example, here write include and task, this line of code, this include, are being replaced with the actual code on the preprocessing step during compilation. So it means that if you write include 2 times, for example here, or in it can be in the another file, and like 2 times in your project, in a complete project, then the code from that class, from the header, will be pasted 2 times, and your executable file will wait more. So using this technique, with defining a macro and checking if it exists or not, we just avoid multiple copies of the header after the pre-processing step of compilation. We also, just interesting stuff, that we also can replace it with the pragma once, and it will work the same way. It makes the same as done it before. But if Qt suggests us to make it in that way, then let's just leave it as it is. Then you see the actual class declaration. It inherits QObject class and has that one QObject macro. That is macro, if you hover your mouse over, which allows you to use all goods of meta object compiler, such as, for example, signals and slots. We can delete it for now. After the macro, you see the constructor with an optional parameter, because you have default value, optional parameter called parent. I previously mentioned that objects organize themselves in object trees, and this is actually it. We have parent, and if you go to the source file, you see it just takes it to the QObject constructor. So okay, let's add a little bit of our code, just so you know what we are writing. We'll have two classes, task and task manager. The task will contain a description property, is completed, like boolean, that shows us is it completed or not, a method to complete the task, and a signal that will be emitted when task is completed. And meanwhile, the task manager, that wants the second class that we will make, will contain list of tasks, like list of those objects, add task method, and complete tasks method that will complete all tasks inside, and a slot to notify when a particular task is completed. So okay, let's start. I will start with the private section. I want to add here first this QString description. I also have to include QString. And of course, I forgot, here I also will change the constructor, because we want to receive a description, because it is required. Every task should have description. And here let's also change it in source file, and just and description to the description. I'll just assign it. Then and you see here prefix m. Why I use it? Because it means that it is member variable. It's the kind of naming convention, you know. And also boolean m completed, that we assign to false as we create our object. Completed to false. Fine. And also let's add the getters for our private properties. So just QString description, I'll copy it just so it's quicker, and bool completed, so we can get description in this completed from the task manager. Of course, we have to implement it. I know it's one line, but let's make it correctly. So if you right click and go to refactor, you can add definition to task CPP. Of course, you can do it manually, but I prefer that way. And here we just return description and description. also the completed and return completed. Before we add methods, method to completed, let's also add, okay, let's leave it in the public section and create one more section for the signals. Here, I know if you come from the just pure C++, it's strange for you, but why it works? Because we have QObject macro. That is the reason why we can write it like this. I'll show you more deeply later after we run program first time. And the signal that we create is with task completed, and we pass here string description. Of course, constant, because we don't want to change it in our slot that will be connected. And that's all what you need to do. I know it seems like it's method, but you don't need to implement it. Signals are just signals. You implement slots. And the last step left for us is to add and implement complete method. Refactor a definition, and here if task is not already completed, just to validate completed, then we assign true to the mCompleted. After that, let's write message QInfo, as I showed you in the previous episode. It's like the easier way to write something. And of course, we should include QDebug header. Of course, you can use also QDebug or wherever you like, but I prefer here QInfo. And task completed. And let's also output description, so we know what task is just completed. And after that, the interesting part is that we should emit task completed signal. When we emit it, all signals connected to this, all slots connected to that signal will be called with a parameter, with the argument we pass in here, and we pass here description. Okay, fine. Before implementing the task manager class, I want to start with something simple and show you how signals and slots work on the lower level, So let's jump here in the main CPP file. I'll delete comments. And let's create two task objects. So task1 is equal to task, I don't know, buy groceries. And let's specify as a parent our application. Here we should put a link to it, just to not leak memory. And when we specify it a parent, we don't have to add that one delete statement at the end. We can just skip it, and memory won't be leaked. And second task, let's say fix bug. Then let's just call complete, and the same with the second task, complete. But now if we run it, nothing interesting going to happen. You can see I run it, and as you see, just task completed, nothing interesting. Okay, now let's add simple function and make it a slot to the signal inside task. And make it slot for that one signal. As you see, we had that parameters. We can receive it. So copy that and go here, void on task completed, for example, and put parameters. I mean arguments, sorry. And here, let's also include one more time QDebug to write some message and QInfo. Let's show that it's our slot task completed description. Nice. So to connect signal and slot, we have one function, static function in QObject. So we can write QObject and call static function, call it connect. Inside connect, there's 5 overloads, as you see, but the simplest one that we'll use now is just when you pass task 1, so the first object, and pointer to the first object, and link to method. Sorry, not method, but signal. And then you just pass name of the slot that is connected. And let's do the same with the second task. And as you see, we can to one slot we can connect those two signals. And now it's more interesting because if you run your program, wait a bit, it's building, and you see here, I hope you see it. If no, now you see it. Task completed. It's message from the task class here, and then slot task completed. So our slot was also called when we emitting signal. Slot is called. We connected it right here, and as we have some code with the meta object compiler, I can show you what QObject macro is actually for. I mean that one macro right here. If you open your directory where your project is located, for example, here's mine, then you can see your, of course, files and build directory. Let's go to the build, debug, and here your build. Let me make it bigger. Inside you can see underscore autogen folder. Go ahead, click it, and here the most important files are that one, MOX compilation CPP. I'll open it. It opens in the Visual Studio Code, and what it's doing is including that file. So if we go here, we can see the actual file with the mock underscore and then name of our class. So if you open it, you can just take a look for the interest purpose. As you see here, warning, all changes made in this file will be lost, and it is not recommended to make some changes here. It makes no sense, but just to take a look, you see here names of our object, of our signal, of parameter we pass in. It's the structure here. Then you see some metadata, and that's all what is interesting about it. And I will show you later that for every QObject class, a separate file is made. So for the task manager, there's also gonna be separate file with mock underscore something. Now let's implement the task manager class the same way. Create, add new C++ class. Here I'll name it task manager, QObject, and here let's capitalize also. Next, finish. Fine. Like the same way you did it with task. And as you see, we also have it in our CMake lists.txt. Okay, let's jump to the header. As you see, structure is the same. And first of all, let's rename to the private and create QList with task pointer to the tasks and name it tasks. Of course, we have to include the QList and include task.h. It's just containing the list of tasks. For now, you can think of QList as of just a list from the standard template library. We will discuss Qt containers in one of the next episodes, so don't worry about it for now. Now I want to add slot to notify when task is completed, and here a public slots. In the same way, I mean, you probably didn't saw that keyword before, but QObject macro allows us to do so. And with QString description. Fine. And now we can add the methods to add task. Task. And complete all tasks. Now we have to implement it, and of course, as I said before, slots are also have to be implemented, because slots, it's as in this example, it's like function. In our case with task manager, it's gonna be method. Let's refactor. Let's add all definitions, and in the add task, we're gonna just first thing is task set parent to this one. So we want to build that like actual parent-children tree. We would build that hierarchy. So not everything is the children of application, but I mean children. But I want to just build that hierarchy, you know. And then connect. And now it's interesting because you see, before we called a static method of QObject, but now because we are inside the QObject, we can call it just as it is. And now it's a bit different, but it will make sense. So first of all, you provide pointer to the object, then link to the signal, task completed, then pointer to the because this is actual pointer to our object that we are in now, and pointer to the slot, and now it's connected. And mtasks append task. Fine. Then in the complete all tasks, let's just make for loop and task and tasks. And here task, let's just call complete method. And if when we call it, then mCompleted is assigned to true, and a message is written and signal is emitted. And when signal is emitted, then our method, sorry, not method, our slot will work, will make something. We will just write message. And here the same as we done it in main. I'll just copy it and make a small change, just not just slot, but task manager. And that's all I want to change here. So now let's jump to the main CPP. I will comment everything we have written so far, because it's another example. And then let's write here. First of all, I want to make task manager object. So task manager equals to new Oh, sorry, I forgot to include it. Don't forget to include it. And here we provide as a parent A. Of course, to not leak memory. Don't forget to do that. And task, let's just copy and paste. Let's make 3 tasks, just so it have some difference. And name it more simple, just task 1, task 2, and task 3. You see now warnings, but they will go as we finish our code. Manager, then we add in it. And oh, sorry, here I copied and specified as a parent application. But now let me show you one interesting thing. Here, as you remember, we set parent, so there is no sense to specify parent here, because parent is also set when we add it. Okay, task manager, add task 1, then copy and paste task 2 and task 3. After it, just complete everything with our method. And after we run, let's see what is happening. What going to happen, sorry. Task completed. And where is message from the slot? Oh, sorry. My mistake. I just put the wrong method. I should put here on task completed. Sorry. And now you see everything is fine. So task completed, then task manager, task completed. And as you see, signals and slots are working fine. And if you open your directory, as I said before, you're gonna have separated files for your QObject classes. So everything is fine, and I think that's it for today. I hope you understood this part because it's really important, and see you in the next episode. Hi everyone, in today's episode we will dive deeper into QObject and all Qt related OP. We will look at QObject structure, all of that, and extend our knowledge about parent-child relationships. As you remember from the previous episode, QObject inherited objects build a parent-child hierarchy. See here, QObject organize themselves in object trees. It helps with memory management because objects can cascadely delete themselves without much effort from the developer. I already created here an empty console app, and now let's take a deeper look at QObject header. Let's create a new object. I will include just obj, and also I want to delete all comments because we don't need it right now. QObject. And let's see what's inside it. If you hold Ctrl and right click at a type name, you can see that header file. If you don't have much experience in C++, probably header files from some libraries or frameworks look scary to you. But don't worry, I will show you where you actually should look at. QObject starts here with the QProperty macro for an object name. When we will start the QML journey, we will talk more about this property and how it works. But for now, you should know that it just creates the property with the getter to read, with setter to write, here with the signal and the slot where when property changed. If you scroll down, here I noted for me, here you see, we can see the getter for a parent. So we can get parent of object. We can also see at line 201 the getter for the children list. Each QObject stores pointers to its children in QObject list. As you see here, the type. Here it's type. Okay, and the crucial thing I should point out here is that there is no copy constructor. By that I mean it is, but not public. So it can give us some problems in the future, and I'll show you when. So the copy constructor is, of course, the one that takes an object by value, not like a link pointer or something, just by value, and copies everything to a new object. And since each child in a QObject can have an arbitrarily large collection of children, it is easy to see when copying QObjects is, why it is not permitted. Because if one object gonna have 5 children and each of those children have 5 more, then copying it could be slow. Here there is more different methods. The main ones, it's like set parent or find children, find child. But now we'll write example, and with that example I will show you how we use them. Here's the deadline. Of course, full code from this episode is in the repository. A link is provided in the description. And if you want to follow along, then start it now, because later I'll extend the code that will be written now. I want to create class here, new class user. Let's copy here and here. It adds to make lists txt, and for now I want to just create the class with the username property. So QString username is gonna be getter, and here let's delete private QString username. Oh, sorry, and include QString. In the source file, just add definition and return username. It's easy. And also we have to change constructor to specify, to specify username. And when someone wants to create a user object, he have to pass username. And if you remember, in QObject we have that object name, and it is not assigned automatically. We can assign it just for our purpose to check it later. So here I want to just set object name. It's method from the inherited from the QObject, and just Q name. Now they're gonna be the same. Now to show you what lack of copy constructor gives us, I want to create a function in the main file, print user. Of course, it would be better to create it inside the class, but just to show you when lack of copy constructor can give you issues, errors. Include user, class we created earlier, and here I pass it just as a value, not pointer, not link, just as a value. Okay, when we pass as a value, object is copied, and here QInfo. We also have to include QDebug to use QInfo and output some data. And here let's do it like this: user info, and then the object. If you don't know what T does, it's like a tab, like 4 spaces in the console. You'll see when I'll run up. Object name is just user.object name. Let's go to another string so you see it. And the same with the username. Username. Okay. And in the main function, I want to create 3 users. So user1 equals to user. I don't know, user1. It's username. Oh no, most oftenly usernames don't have spaces, so let's pass underscore. And I'll specify also parent to not lack memory. Sorry, leak, not lack, leak memory. User2 is we will create pointer to it, so we will create on heap user user2 and the same, sorry, the same. And the third one, let's name it user3 and specify the same. Oh, and okay, sorry, I forgot. We have to, of course, use new operator. As you see here, we can have the memory leaks, and I want to print user. Print user, call the function. First is user1, just passed by value. Second, print user, but here, because we have pointer to it, we have to use that asterisk operator to pass the actual value. And print user3. And as you see, we can't actually compile it, we got 3 compile errors, say call to an implicitly deleted copy constructor. It means that we can only pass our QObjects as a pointer to avoid copying, and we just can't compile program like this. Now let's make it correctly. So we pass it as pointer, and here we use that one operator. And let's also show the parent. And so the same thing. Parent. Let's use parent object name. Then I also want to print out all children names. So here we can get inside QObject list. I use lint to avoid copying. Children, and we should include it also. Object list, and then with the simple for loop, iterate over it. We'll talk later about containers and method inside some like QObject list, all that. But for now, I mean, it's obvious what method called length returns. It returns just length of the container. I mean, number of childrens inside it. And okay, info. Child. Let's also give something like index to it, and to not start it with 0, because I is first 0, we add 1. So we're not gonna get 0, 1, 2, 3, but 1, 2, 3, 4. Then object name. Okay. And now we can use it correctly. So here I pass it as a link, and here just pointers. As you see, we don't have any errors, warnings or something, and we can run it and see our output. I don't know if you see it good, but you see object. What? Object name. Okay. Object name, username, parent. Just to test, we can specify here user1 as parent. So you see, parent here is user1, and here child number 1 is user2, that one. And we can do similar here, for example, and just we have pointer, so I don't have to use operator. As you see, child 1, parent. That's how it works, and everything is deleted after program has finished. We'll create a little chatroom program, and it will be the main example in this episode to wrap up new information. Remember that we made task and task manager classes in the previous episode, and we built a good parent-child hierarchy and set task manager parent as an application. There weren't memory leaks, but now I want to cover the situation when our kind of manager class doesn't have a parent. First, just to make some good example, let's add the signal and slot to the user class, and signal is gonna be message send QString sender username. I pass username and not just user, because later I want to show you one more interesting method inside QObject to find the child. QString. Then public slots. Message. Okay, I have to add definition to user CPP and just emit message sent signal, username and message. Okay, then I want to add new class called chatroom. Make it QObject. The chatroom will have add, remove, and send message methods. But we'll also implement the structure to clear everything from user list in case the chatroom won't get a parent, as I said. I don't know if you see. I hope you see. Okay, so first constructor we have it, then add user QString, then remove user, then destructor, and let's make a slot. We don't want signals here, just one slot. It's a private one. When on message received, sorry, received. So here we get the same as sender username and message. And also we need a private section with the QList. It's like this simple container, don't worry about it. We're not gonna use some hard methods, just add elements. It's the same as it's the same list as you know from the STL. I mean, very similar. Okay, so include the QList, include QString, and include user object. Also, let's add the definitions. In add user, we just create new user. New user equals to new user username. And as a parent, I specify this chatroom object. Because when chatroom is destroyed, then the users from the user list should be deleted. And connect. We connect signals and slots. So here I specify user message send. It's our signal. And then we specify this object. So previously, as I said in the previous episode, I think previous, we first specify that object with signal, then our object with slot, and link to the slot on message received. And we have to, users is the list we created, and append. So we add new user to it, new user. And also I want to here include QDebug, include QDebug, and write some message. Write QInfo, username, join the chat room. Then the second method is remove. So we just remove it from our list. And let's go like this. And here we have username passed. We need to iterate over all list of users and check whatever username is matched or not. So for user, here I use just for each loop, but we can use the easier one with from I equals to 1 to let's if username is equals to username provided in parameter, then let's also QInfo it. Just not join it, but left. Okay, M users, remove one, and remove one just removes element we provide. And also to not leak to memory, delete user from here from memory. And we can return to not to just end our loop. And I don't want to use here break, because if no user with that username is found, then we should write some message. So is not found. If you just break the loop, then this message will be written. But if you return and then all method gonna be ended. Then we have destructor, and here is the interesting one, because see how we clear the list at the destruction stage. First, I use QDeleteAll function provided with Qt, and this function it deletes objects, but not clears it from the QList. So later we have to call also QUsersClear to not leave dangling pointers. So as I said, we do it because QDeleteAll deletes object but leaves dangling pointers in the list. So we always have to clear it. If you skip clear, then the list will be left with elements, but users have already been deleted. It's the problem. So first I QDeleteAll, then clear. Let's go to the main function and test what we have written. I want to, let's comment it out because we don't want this example. I want to include just chat room because chat room includes user, and there is no sense to include all two things. So chat room. Then chat room, let's add, for example, it's just a string. I don't know, Alice and chat. Oh, sorry, not char, chat. Bob. Then we can to send some messages with the help of that signals and slots we specified in the user class. We should find the user object, and to do this we can call, let's use just autumn. First is Alice equals to chat room find child. Find child method is provided from QObject, and here we can specify the type, and here just write username because it searches it with the object name. An object name I specified it here. So when we pass to add user Alice, let's go to the chat room. Here it goes to the username in user object, and user object set it as object name. And find children finds it with object name. Okay, and the same with the Bob. Maybe let's do with capital letters. Okay, and if it found it, so if Alice, then Alice send, sorry, send message and send hello. I don't know. And if Bob found it, then Bob send message hi. And then just a test method for remove. We can remove just one of them. The username Alice and user left for us is Bob. We can also it's one Alice and one it's just ABC, not an existing user. So we will get a message it's not found. And as you see, chat room doesn't have a parent, but we did not leak any memory because here we have destructor and clears, deletes and clears everything. Let's run it and see the output. Oh wow. Wow. I have error. You know what? I was in a little bit hurry and forgot to write definition for on message received. I'm sorry. Let's do it right now. It's small definition, so we just queue in for the sender, username, and message the sender wants to send. And now if I run it, then you see all output correctly. So Alice joined the chat room here when we edit it. Then Bob joined chat room. Alice, we found Alice and found Bob. Alice sent message hello. Bob sent message hi, and Alice left the chat room. And we've tried to remove also a not existing user, and it is not found. But we didn't leak any memory because in the destructor deleted and cleared everything. I think this is it for today. In the next episode we will discuss smart pointers, and thank you for watching and see you in the next episode. Hey everyone, in today's video we will discuss smart pointers. I will start with what it actually is, then cover cases you most likely will use it, and finally show how to use all types of smart pointers given by Qt framework in code. But what it actually is. In simple words, smart pointer is just a wrapper for a row pointer with the garbage collection. There is no single smart pointer type. As you see, we have many of them, but all of them try to abstract a row pointer in a practical way. A smart pointer, by comparison, defines a policy to when the object is destroyed. So still you have to create the object, but you no longer have to worry about destroying it. Qt framework provides us a wonderful way to manage memory with the QObject relationships. And you're probably curious why we should use smart pointers. When your class inherits QObject, you most likely don't have to use them because it is going to be overkill. But sometimes when you develop Qt apps, you can eventually need to have a row class. That is not inherent in QObject. And this is the case for using smart pointers. So, okay, I want to start with shared pointers. Shared pointer, shared data pointers, and Q explicitly shared data pointer. Because it is not hard to understand, and you will see how in most cases smart pointer types differentiate. And also the main purpose of those last two is to help shared ones, so you have to know it. Okay, let's start with QSharedPointer. And it is the most general of those three. You have here a lot of methods. I will show you an example. And it behaves exactly like a normal pointer for normal purposes, including respect for being constant. QSharedPointer will delete the pointer it is holding when it goes out of scope. Provided no other QSharedPointers, the pointer objects are referencing it. Or with simple words, it helps us share access to the same object and becomes deleted when it is out of scope. So let's write quickly a few lines of code as an example to start shaping your understanding of smart pointers. In this example, we'll create class with the constructor and destructor to see when they are called. So class, I will call just my object with public section, my object as a constructor, and it's gonna be just, let's include QDebug, and also let's include QShared pointer. I'm gonna be QDebug, and my object is created. And also let's copy and paste, just make it destructor just when it destructs. When you suggest row it. And I also, no, I don't want to make anything. Let's delete comments. In this episode, we're gonna have a lot of like small examples for all types of smart pointers. So I will make functions for it, and they will show the scope where pointers are located. And of course, all code I will write today is in the GitHub repository, linked in the description below. Okay, wait, let's name it E1, then E2, E3, like example. Okay, and in this example, let's create QShared pointer of type my object. You have to, if you know smart pointers from C++, then it won't be hard for you. You have to specify here in template type. And we provide new my object without any parameters, because only constructor we have is without parameters. And as I said, it can share access. So the second one is going to be also QPointer my object, and it's ptr2 equals to ptr1. Okay, but it's not pointer, it's like just object. No, and I make it in the scope, this example one, because I want you to see when an object destructs. So, and notice one thing, we make two variables, but with only one object. Here, if let's add new property, QString, just QString, let's name A, doesn't matter really. And ptr1, we can access it with this operator, A equals to, I don't know, ABC. And then if I QDebug A, but it from second one, we'll get the same. Here, if I call it E1, let's run. And as you see, object is only one, but we have two pointers. So it behaves like a pointer, it shares access, and that's how it works. And at the end, it destroys it. Under the hood, it stores a reference count, and while it equals 0, deleting object. Most methods are self-explanatory inside, if we go here. But the most important ones are get and just data. Let me show you it here. Get and data. just return value is our row pointer. Just return it as constant. Then important one is clear. Here we have clear. It just drop in the reference, and maybe here we have reset. It calls just clear, but also have 3 overloads. So in the simplest case, it just calls clear. But it just resets smart pointer to point to another object. As you see, the simplest one just clears. And one more is swap, also important one. It swaps pointer to other instance. And notice that it marked as no except, and hence it very fast. Okay. Next smart pointers will look pretty much the same inside, but will only add a new method or more overloads for old ones. All smart pointers are similar pretty much, but just add some new feature. The next pointer we'll talk about is QSharedData Here we have it. If you compare that name to the previous one, notice the word data added. It probably means that it cares about data more or something. The main purpose of it is implicit sharing with the copy on write, or simply co rule. It means that whenever two smart pointers looking at the same object and first is changing, then copy will be made, and changes won't happen in a second one. In the next example, we'll make a separated object because it should inherit QSharedData. Let me show you what I mean. We can probably close it, or no, we can just copy them because class is similar, but I just want to show you difference. And it should, let's name it my shared object, for example, and also rename everything inside. And it should inherit QSharedData. We should inherit object for the classes that is used with the QSharedData pointer and Q explicitly shared data pointer. It should be inherited. Okay, so let's make another function e2 and say that QShared, and of course we have to include everything QSharedData pointer. Shared data pointer, my shared object, ptr1, we pass here new my shared object. Then let's say ptr1 that string is equals to abc. Then let's make two more pointers, and ptr2 gonna point to ptr1, and ptr3 is gonna look at ptr2. Okay, then let's try to change value in ptr2, and let's say a is equals to, I don't know, QE, just random characters on my keyboard. And then let's QDebug everything that we have. So ptr1 a, and then copy and paste second and third. Notice here, look careful, we assign in the ptr1 a equals to abc, then ptr2 is equals to ptr1, and ptr3 equals to ptr2. So they share the exact same object. So for now, they share the same object with a equals to abc. But next, we assign ptr2 to a, to equals to qe. And then if we print it out, let's see. Sorry, I didn't call it. Here I call e2. And then let's see what we got. QE. Oh, sorry, my bad. It's I just looked at it and it looked just strange. Here we should pass Q. Sorry, my bad. Q shared data pointer. Yeah. Now let's look at what I mean to you. Here you see the second one is equals to QE, but first and third ABC. Why? Because as I said, the main purpose of the smart pointer is implicit sharing with copy on write. That thing is have simply a copy on write. If you ever saw co, it means copy on write. Okay, that rule. So here, when I changed value inside, it just made copy. And okay, now we will jump to the next one, and I will also notice how it do it, how it doing copy, and we don't know about it. And the next one from the shared category is Q explicitly shared data pointer. It is very similar to the previous one, but what means explicitly? Here we have explicitly. The thing is that whenever we change some property values in one of those two smart pointers, the touch method, we have here the touch method, and here we have the same in QShareData, the same one. Method is called. As documentation said, if the shared data object's reference count is greater than 1, this function creates a deep copy of the shared data object and sets the pointer of this to the copy. What it means is that, I mean, here I read from here. So whenever we share data with more than one pointer and data is changed, then this method should be called. And when we do it with Q shared data pointer, it makes it automatically. To see all of it in action, we'll write a bit bigger program with Q explicitly shared data pointer, and then quickly rewrite it to use the previous one, I mean that one. So you will see the difference. And now let's create new class, but I don't want to separate methods to the source files and header files because methods will be really short. So I will write method implementations in the header, just not spend time. Employee data. The first one I will name class employee data. And here, let's include everything we need. QShare data, include QString, because for the first one, this employee data is going to be just a class to store employee data, and it will be QShare data inherited. So QString, and also we will need probably QDebug, I think. Okay, class employee data inherited with QShared data public Then let's write constructor. And okay, before writing the constructor, real one, and it should be public, of course, I want to make properties. The first one will be ID, then QString, let's say name. And here, the empty one, we will just specify ID as -1. And let's write message qdebug employee data is created. Then the second one, it will be copy constructor. So from the previous episode, you know that QObjects don't really have copy constructor, but here it is not QObject, so we can make our things. Okay, it's gonna be constant order, and just here we should pass everything in. First is QShare data. We should pass to the QShare data constructor this other. Then ID is other.id, and name is other name. So let's put it on the second line, and here also write a message. Maybe it's copied. And the last one is gonna be destructor. When we destruct, destroy our object, destroy it like this. And the next class we will create is actually gonna use this Q explicitly shared data pointer, smart pointer. I mean, names are long, it's hard. Employee. And here I will, let's create class without class not inherit anything, because there is class to like kind of manage the previous one we created. And here I want to include employee data, and here in public section, no, let's firstly in private create the main thing we here. It's explicitly explicitly shared data pointer with employee data and employee data, name it just D. And then we can make all constructors and all those things. Here's D equals to new employee data, just like this. Then employee into ID, where it's the case where we pass some data. Name, not pointer, sorry, just link. And here we say D equals to new employee data. Then as to set ID, let's create another methods. It's like setters for our smart pointer because it's private. And now set ID. We're gonna have int ID, and it ID get ID equals to ID. As you remember, get method just gets the row pointer. And here we can call set ID. But let's make the same with the string, with this with name, with string, and I will show you where we made a mistake. QString, sorry. string name get name equals to name. Okay. And here, as I said before, when data is changing, the touch method should be called. QShare data pointer makes it for us, but in this case, we have to call it manually. So after we change something, we have to detach, call it method. So if two objects sharing the same object, copy gonna be made. Also, we can make quickly getters. So id, it's constant method d id. Also the same with name, but here is QString. And so d name. And also we can make the copy constructor for it. Employee and everything that we should copy is just a smart pointer. Then let's go to the main CPP and test it out, and I will explain you a bit more about what I done. Not employee data, just employee. And let's hide it and make E3 example number 3. So QDebug. Let's make messages just to know where we at. Creating employees emp1, and we actually created. ID, I don't know, 1, 2, 3, and name John. Then QDebug, copy emp1 to emp2. Debug, here we copy the same data, and then I want to modify it and show what will happen. So we modify emp1 and let's set e1 set name to the, I don't know, Bob. And notice here that those shared pointers are mostly used for internal implementation of implicitly shared classes. So what I mean by that, the most frequent use case where you use shared smart pointers, it's like how I done it here. I create one class with the data, and then one class with the smart pointer, and like for internal implementation. As you see, we manually call detach, and if we don't, then the object wasn't copied, and we will see only one message from the structure. Let me show it. So here, oh, no, I forgot to call E3. As you see, we have two messages where when it's destroyed. So that means we have two objects, not one, and it was copied. So creating emp1, then it is created, it's a message from the constructor, then copying is, then we modify. So we write employee data is copied when we set name. So when we set name, here see the detach. So the data was copied, object was copied, and then we get this message for the destruction 2 times. And if we change for and just so you see, for example, let's comment this when I call the touch methods, what will happen? You see, only one time it is destroyed, and so it is not really shared data pointer because we didn't call it. So explicitly tells us that we explicitly should call the touch method. And if you want to remove it and not use that, you can just use shared data pointer, and it will work the same way. You can run, and it's all good. You see, two messages. But the important thing is that if you want to share functionality, to work properly, you must call this get method. Okay, not forget to use it when you change some data. The next pointers we will look at, just let me hide it, are QPointer and QWeakPointer. And names are not very fancy, so those are going to be easier. The first one is QPointer. Let's include it, QPointer. And even though we will only take a look at functionality and the most frequent use case, I think you should know that Qt in previous versions deprecated QPointer, then let everybody switch to QWeakPointer, then they removed QObject tracking capability from QWeakPointer, so we have to use QPointer. Okay, enough crying. The main purpose of the QPointer is a weak reference to a QObject. It automatically sets itself to null PTR if the QObject points to is destroyed. In simple words, we can only make a pointer to QObject, inherited object, and we have to delete it before the point because the pointer is weak. But you'll probably ask, like, I mean, delete. Okay, just if my token is not enough explainable, you can only create. You can only point to the. I'll create QObject, my QObject like this, to QObject inherited object. And you also gonna need to write this delete thing and at the end. But why we use it? It does why if it exists if not give us garbage collection. And the thing is, pure pointers after deletion become dangling ones. So after deletion, we want it to be null PTR, and QPointer just help us with doing this. Let me show you an example, and you will understand what I mean. So let's say public, as in previous examples. Okay, let me copy it because it will be similar. Just I will change this, and it inherits QObject. And I create its yes, example 4, and call it, just not forget later. Here, let's say we create QPointer to my QObject. Obj, new my object, and this. Okay, we can also. Yeah, let's quickly create change this constructor to past, not take another line. Just like this. Let's say ABC. Then we create the second object, second pointer. That's obj2 to obj just. Then we can QDebug to see that obj get a, they are the same. It's like the same object. They also sharing it. And if you write here obj get a equals to, I don't know, some other things, some text, then and then QDebug all of this, you will see that it's also one object. And at the end, you should always write delete obj. For now, just let's run it. As you see, it's the same one object. And we delete it because, and why we use it just? Why we use QPointer instead of row pointers? Because when we write delete, obj is not dangling pointer, it's null PTR. And it's good, like you don't have to write obj equals to null PTR like with row pointers. And then we can check it. So we have a method called isNull, and let's QDebug also. And if it is null, then let's write obj null PTR. And then the same with the second, not obj. Let's run and check. Yes, it is null PTR, and that is good. And if we remove deletion of object, memory will become leaked. So as I said, just do not make them dangling. The next one is QWeak pointer. Here we see I go with list Q pointer, QWeak pointer, then gonna be scoped, but doesn't matter. QWeak pointer is a weak reference to an object managed by Q shared pointer. Its main purpose is to observe an object without owning it. Let's say you have a shared object managed by Q shared pointer. You have that one object with this pointer. And multiple parts of your code might share ownership of the object. Like here you have this pointer, here, in different parts of program. And it can create a circular reference. For example, an object holding a Q-shared pointer to another object that also holds a Q-shared pointer back to the first. You understand? Like then it becomes circular, one to one, just. And the reference count will never drop to 0. And the objects won't be deleted, even when they should. To solve this problem, we have QWeak pointer that can be used to break the circular dependency. It observes the object without increasing its reference count, allowing proper cleanup when the time comes. So if I want to draw it, let's paint. Here I have one shared pointer, here I have another. And like they can make circular dependency. With the weak pointer I can break it and all objects gonna be deleted instead of making memory leaks. Let's write example for this. Now I will not use some additional classes, just with the integer. It will be easier. So void e5. Let's make your shared pointer with integer shared ptr is equals to your shared pointer with integer create and Just it's instead of calling constructor, we can do it like this. And then let's create QWeek pointer. Also int week ptr is equals to shared ptr. Then we can check, just as in previous example, if week ptr is null. And let's QDebug. The object is still alive. Then when we make shared ptr clear, let's check, sorry, Q, like this. Has been deleted. And let's call it. And everything works properly just as we expect. When we clear, it's deleted, like obvious, you know. But if we change QWeek pointer to the QShared pointer, let's just try it. Here's what gonna happen. What? Why it is not deleted? And you can see that the object is not null ptr, and we left a dangling pointer, so we have problem. So in this case we can use QWeek pointer just to delete it properly. The only two smart pointers left to us are QScoped pointer and QScoped array pointer. They are like to each other and not so hard, so it will be quick. QScoped pointer provides us exclusive ownership of dynamically allocated objects. It means we cannot share access to the same object between many pointers. But the important thing I should mention is that Qt started to deprecate it to encourage us using unique ptr from the standard library. And let me show you what I mean in code. Hide the previous. And let's go E6. Here I want to include it quickly. QScoped pointer and also QScoped pointer array, because I will use it in the next example. So QScoped pointer of my object, let's just use that first object we create, just empty, not inherited from anything. Have prints the, output to the console statements. Yes. And we create ptr new my object with some text inside abc. My object. No mention what? Oh yeah, sorry. Let's just create one more. Probably I forgot to edit. Just like this. And it will work. Okay, and as you see, if we run, we create and then destroy, as expected. But what if we want to move ownership to other pointer? Because, you know, if we want to like write ptr2 equals to ptr, ptr, then call to delete the constructor. We can do that. The purpose of that pointer is that we can't share the ownership. I mean, we can't, but we can. But if we want to move to the other pointer, like we can do it probably, yeah. And we should use ptr. Let's here ptr take method. If I do it, it will work, of course. Here pt oh sorry, it's like here, like this, because take method, if you search here take scope, where, oh probably we don't even have it, because I'll show you why. So you see, take is deprecated. Use instead use unique ptr with the call and release instead. And I don't know, if a few days it worked, but for now, let me check. There, it's like, and then if I want to delete it, I'm just curious if it will work, because it should, even though it's deprecated, but should work. Yes, it worked. Okay. And to not get error, warnings, we have to use unique ptr from the standard library. So unique no, it's not, sorry, header called memory. Yeah, my bad. Header is called my memory. And here we can change to std. Unique ptr, my object, create, and then call the release. As warning suggested, release us. Yes. And if we run it, it will work. I know it may seem strange because Qt is a framework and why should we use standard library tools, but they want us to use more modern tools. And similar rules applied to the next smart pointer, specifically QScoped array pointer. The difference between those two is that QScoped array pointer manages array and accordingly deletes a full array at the end. So we can write void e7 7 example. Here let's create QScoped array, scoped array pointer to the main my object. Let's call it array new and create with the line of 5. Let's assign some values to a. So int t equals to 1 minus 5 plus plus a time equals sorry, a, it's the text inside, equals to, let's say, obj number, and we can use static method from QString. We'll talk about QString in depth in just second, sorry, just next episode. So you have to watch it, and we'll talk about all methods inside. So Q number on I, this we assign this text, and then I want to print it. So QDebug array I, sorry, R, like this. And if I want to take it, I will get deprecated warning, like the same way I done it before. I even can copy str2, let's say like this, take, like the same way it was before. Maybe let's name it just R2 or row. Yeah. And here print it. And then of course delete. Delete all array. You see, it will work, but with warning. So to avoid it, we can use std unique pointer. Then here we need to use get method, because unique pointer don't have overloaded square brackets operator, and here leaves like this. Yes, unique Peter doesn't have additional class for arrays, so we have to use get method before searching in for index. And let's run, check how it works. Sorry, it's I didn't even call it. Okay, sorry. Now I called the. You can trust me. It will work with the take, but you're just gonna have a warning. And here, as you see, everything is destroyed without warnings. And okay, we covered all kinds of smart pointers, and I think this is it for today. I'm a bit tired. Thanks for watching, and see you in the next episode. Hey everybody, today we have such a comprehensive topic that may not be very hard, but it is huge and important. We will discuss the QString. The one important thing I want to mention now is that QString class is not QObject inherited. I will quickly show you. Right here, QString, and include QString. And call constructor. Then go to this class. It is not QObject inherited. So when I said that pretty much everything in Qt is inherited by QObject, I meant that those data storing objects are mostly not. So watch the full video, because I will explain most of the methods and it will save your time in the future. If you are very new to programming, the string is a bunch of characters. Each character is a separate object of the type qchar. Qt provides us a QString class, so we can easily manipulate 16-bit qchars. Earlier, we had already touched QString in previous episodes, but we have only created it and assigned it. Now I want to cover more useful methods, and as you see in documentation, we have a bunch of them. But don't worry, sometimes it is even obvious what they are doing with the name. Okay, let's go through that list of public functions. Constructors have many overloads, but as you see, most of them are used for compatibility with other types of string, or just to copy strings. Like here you have this for compatibility, this also, because QLatin1String and QByteArray is also representing strings, and we will talk about it in next episode. Then this one, it's also about compatibility. And the last one, here you have move and copy constructors. So let's create a few strings for testing purposes with the different kinds of constructor. I'll go to my editor. I hope you already know how to create project. I'm not how I'm sure that you know. And let's create QString. Let's call it str1 equals to just empty constructor, as I done before. So it just creates, we create str1 as an empty string. And then let's create str2 and pass here some text. In str2, we pass an array of chars, because as you see, the type here, no, you don't see it, maybe here, yeah, you see here, const char 10. The type here, one of possible is const char str, and there is pure C++ string. I would say like that. It's just pure C++ string. Okay, and let's also create str3. And here pass size and the character we want to fill it with. As you see, now we have also a constructor for that. Here, we pass the size and character we want to fill it with. If you think about it, it may look strange because we pass pure char from C++, but the type in the constructor is qchar here. But it works because qchar has a constructor for char. Here I open it qchar, and you see, we have a constructor for char. Also notice here that QSizeType is a pseudonym for another type. Let's go here. No, I want to open here. I want to open this constructor, then QSizeType. You see it's QInteger for size of and this long type. Okay, and then let's print it all. So let's just create one helper function to print them. Print all, and pass here 3 QStrings. Okay, let's include QDebug to use this QDebug to output some data in the console. Let's also write that star1 and then we just pass it. And let's see what we got. I'll increase the size of my output. And here we have it. First is empty string, then just some text. And the third one is 10a characters. The next method is append. So it simply adds a character or string. You see here we can pass character or we can pass string or other compatible classes to the original string. We also can pass this kind of string, and I will show you how to do it. Okay, let's go to editor and let's write, for example, star1 append. Just first is simple string abc, for example. Then str2 append. Let's test the qchar. And third one, I want to show you how to add this kind of string. And firstly, we have to create it. So it's gonna be const qchar. No, not this. Sorry, I mean this. Qchar c equals to new. We specify length when we create that array of qchars. That's, you know, B, C, D. And then we can str3 append C. And also, here, as you see, we should provide length. But what if we give, for example, 2, not 3? Let's see what will happen. Star1, star2, and star3. Let's see what we got. And here is it only adds first 2, because when we create array, that kind of pointer thing with its array, we should provide also statically length. And if we give 2, then it will add only 2 of 2 elements of array. So the first one adds pure C++ string to the original QString. The next one adds next one is adding one character, and the last one for the last one, I create an array of qchars and append it. And I can specify how many characters I want to add. Okay. Oh, and also, I'm sorry, I pretty much forgot. Sorry, we have to, of course, delete all array C, because it's pure array and it doesn't have some garbage collection. So we have to delete it, don't forget, because memory gonna be leaked. I executed it once, so I leaked my memory. Sorry if I leaked yours also. You have to delete it. Sorry, just sorry. And also I want to here write some comments just to separate things, because of course code will be in the GitHub repository in the description if we want to compare or copy or something. Okay, constructor, then append. Okay, so next method, it's arg. I will make comment for it. And okay, this method has a bunch of overloads, as you see, a bunch of them. And I will show you how to use them, because this method is really handy. Okay, let's create new string called QString just str, and write here name %1 age 2. Let's specify that it's in meters. %3. And here, this arg method is working with percentage and this number things. So on this place, some value will be inserted. And sorry, I talked and forgot. Okay, now let's try it. I don't want to create new variables for the results, so I will just QDebug it quickly. So okay, QtQuick arg, and for example we can specify it Bob, then 30 years and meter 80 here, one by one. So if I run it, let's see. Here I have name Bob, age 30, height 180. Okay, but if you want to pass other types, do this. QDebug arg, and here we can pass first of all Bob, then arg, because this thing returns a string, and because of that I can output it. Then arg, I want to pass here integer, so let's go, and here I want to pass float. It's gonna be double, okay, because I can specify so it will be float, but it will be double right now. I can make it float like that. Let's start and see. Here I have pretty much the same result, because if it's double, then zeros can stretch. And as you see, overloads for that are here. So for the char, int, and so on. Or in the first option, it worked because of that overload. Because of, sorry, this overload, I hope. Okay. The next, let's say, category of arg method is inserting a string giving more functionality. So I talked about this. Here, let's see how to use it. QDebug str arg. Let's say Bob. Then we can specify field width. Field width is just how many symbols will be taken from this string. Let's say here 5, just for some reason, and the last one is filter. So if this number is more than length of provided string, the rest characters will be filled with the thing that we give. So let's take a look. And here you see Bob. It filled like this because we specified 5. Okay, the next 4, I hope 1, 2, 3, 4, yeah, are doing the same things but with the compatible classes: QStringView, Q1Latin1String view, and so on. I want to show you another one interesting. Let's go to the next line and arc. Let's say 120, 10, QChar. I will show what it does right now. This one is interesting because let's go here. We use this overload. And you probably understand what other parameters do, like integer a. Okay, we specify what we want to insert, then field width, how many symbols it could take. Okay, I specified 2, so but 120 is 3. Okay, then base. Why do I put it here 10 and by default is 10? This parameter, yes, you so called base, and it means the numerical system I want to be interpreted. If I put, for example, 8, then it will be octal. If I put 16, then hexadecimal. So let's try 16. Here we get 78. You are probably also wondering why I explicitly converted char to qchar, because the method has lots of overloads. So here has lots of overloads. We help the compiler to resolve them. If I remove it, we'll get error. So we help compiler to resolve it and know what it should use. As you see, we have similar types. For example, long is also, it's kind of like int, but longer, I think, q long, and so on. But what about double? Let's try to use it. Because we have one new argument, for no, not one. We have format and precision and what it does. Let's see. So in the same, let's go arg. And for example, just so you know how it works, let's put it like this. Let's start. You'll just see. Then I'll explain. Okay, what just happened? One by one. It's not the correct way, what I showed you. Oh, sorry. Here, what we got? Double A. Okay, we gave double that we want to insert. Then field width. Okay, 6. It's more than, so we have here the minus. And point is also taken 1, so 5 and 1. Then G. I will now give you the full list of possible ones. G is just general format, and the number is displayed in the shorter or fixed point or scientific notation, depending on the magnitude of the number. I read it from what I know that so far I don't know that intelligent words, so I'll show you the full list what it does that I found. Okay, the next is precision. For it just about this. So if I, for example, put 1, here what I get. It's just rounded to this. So it does exactly it. Let's put 3 and it should be in correct way. Pretty much. Okay, we can put 4. And here put also 4. Because we don't want any minuses in our height. Ah, okay. Because it's about this format. Okay, sorry. If you put 4, if you put F, you got it like this. And here, it's right. Okay. As you see, you can experiment a bit with those values. It's interesting with the floats. And okay, let me show you the full list of possible formats. I'll just copy and paste them. F, fixed point notation, number of displayed in standard way. In standard fixed point notation, just like this. Is a scientific notation. Is just like you can see on example what it means. G as I used, depending on magnitude, and G the same but uses uppercase letter for the exponent in scientific notation, like this. Okay, it was a pretty long method. Let's jump to next. Assign method is used, as you probably guessed, to assign another string to our string. It, as you see, since 6.6, Qt6.6, so it is brand new method, and you can notice here pretty strange types that you probably didn't saw earlier, called QString, QNStringView, and not Q, just input iterator. Really, QStringView is simple utility class introduced in Qt6.6 that supports all string representing types you can think of. Like it's the same as, like, it can represent QString, QLatin1String, QStringView, and standard C++ strings, raw characters, character arrays, and so on. Input iterator is a utility that supports both Qt and STL iterators. Like you have iterators in, for example, string, I'll show later, and iterators in vector in STL library. So it supports both. So let me show you how to use it. First of all, let's create, for example, just to show you how to use it with different types, let's create QLatin1String view. Let's write Latin str. Let's put here hello. Then let's create, I want to include string from STL, and I want to include vector from STL. So let's create std strings. And std vector of course characters. So it's vector str. Word. And now let's try to use it. So str1, just str that we created earlier. I won't create new strings. I'll just use it in all our examples. First assign. Let's try QLatin1String view. As it works, I mean, we don't have any errors. So let's QDebug it, str, and see what we got. See, it works. Just hello. And then we can also assign this string from STL library, and it will work the same way. It works because we have this QNString view. It's beautiful. Let's see here, we have world. Then let's try to do this with the vector. So str assign, as you remember, we have first the iterator and to the last. And I think you know how to get iterators from vector. If no, just copy me. Begin and str and maybe just to test we can hit -1 just to show that iterators works. Iterator works. Let's try. Not word, just word. And just to show you that with our Qt strings, iterators can also work, let's do pretty much the same stuff with QLatin1String str assign and QStr from the beginning. Let's make +2. We can make the same operations with iterators that we make with the STL iterators. And QStr and also I forgot to make comment, sorry. Assign. Let's start and see if it works. See if it works. I don't output anything. Just so. Okay, here as you see. And if you don't know what iterator is, you can think of it as a pointer to an element or like to a character. Most iterators have addition and subtraction operators overloaded, so we can easily jump to near standing elements. It's a simple explanation, as quick as I possible can do it. Text method is add is used to get character on a certain position. But of course you can also use square braces operator. I'll quickly show you example so you know. And so we can just QDebug str on, I don't know, second position. We have here LLO, so we're gonna get O str at 3. If I run it, sorry, 3. Okay, now we have this error because index must be in the range from 0 to length -1. So if you provide wrong index as I done, you'll get an error. Now it will work correctly here. And but don't worry to also to use square brace operator. It works just the same way, as you see. Back gets the last element of the string. If the string length equals to 0, you'll get an error. So let's try. Let's QDebug. Steer back. And then let's just for testing purposes make the string empty with the length 0 and try to call it. We'll get error. Here as you see, assertion error. And in the first case, when we have something, it just gets the last element of the string. So I'll comment it because I don't want to get any errors. Let's go next. We have begin. In one of the previous examples, we used it. So I won't explain iterators here because it is basic stuff and you should know it from some beginner C++ tutorials. But begin just returns as iterator to the beginning of the string. as we done it here. Just iterate at the beginning of the string. Let me just quickly show you example. QDebug str begin. We can just get it like that, or let's make a second, and also let's assign something. I don't know, ABC. And we can of course get the value from iterator with the asterisk operator. As you hear, we just get place in the memory because it's pointer, and here we get value from this pointer. So the next one, we have here capacity. Capacity returns the maximum number of characters that can be stored in the string without forcing reallocation. Classes like QString dynamically allocate memory when the count of elements is bigger than capacity. It means that we have certain capacity. Let's say here, I will try to draw it. We here have some capacity. No, let's don't use title. It's our capacity. And capacity can be like this, but our string only have this much data. That you can understand it in that way. So let's try it with our str. What we will get? Interesting. Debug. First, let's write str just to see what we have, and then str capacity. Sometimes the numbers are not so obvious, you know. Capacity. We have ABC, we have only 3 characters, and capacity is 32. As you see in the output, we have 32 capacity, but the length is only 3. Why? Earlier, we assigned different values, and the longest one was probably here. Probably here we assigned the longest value. It was something like that. I think, yeah. And I don't want to count how many is it, but when the string grows, Qt typically increases the buffer size geometrically. It means that doubling the size or growing by a constant factor. I mean, it could be like length multiplied by length when we insert so many characters. And then C, begin and C end are not very interesting. They just return the same iterators but constant ones. So I can just, let me just copy and paste example. So you see, it's really not that interesting. Here, just remove. I mean, you can use it that way. A constant iterator, as you heard here in name, we can't change it later. We here can say -1, but then we can't. And you see what we get. But don't forget here some interesting thing. First is cend, and we get null. So don't forget that the end iterator is standing on empty space. That shows the string where the end is. And to point at the last character, you should subtract 1. Here we have last character. Then we have chop. Chop removes characters from the end of the string. We can specify how many characters we want to remove chop, and it will remove. So let's say str is equals to A, B, C, D, E, and then str chop, let's say 3, and let's see what we got. AB. It just removes last 3 characters. And important thing that if you, for example, you have now lines 2, and what if you will write chop 5? Then pretty much nothing will happen. You won't get any error. It will become just empty string without any exceptions, errors, issues, crashes. As you see here, just empty string. The chopped method differentiates only in the thing that it creates a brand new string instead of modifying the old one. So here you see it returns void, but and it returns QString, brand new, a copy. Chopped, and let's say str is also equals to the same. And then we can't just write it like that. We should, let's say, QDebug, and inside it write chopped 2. And if I now QDebug just the string, nothing will happen. Because, as you see here it chops, here not. Because it returns just a new string and not modify our. The next one, clear, as name suggested, just clear string. Let's quickly test it. Str clear. What will happen? It will clear our string, so we will get empty one. Yes, just empty string. The next one is gonna be compare, and compare is maybe a bit not logical, because how you can compare strings and get integer, but wait a second, I will explain you. The comparison is based on numeric Unicode values, and it also can compare both case sensitive and case insensitive. You can specify it here. Case insensitive or insensitive. And let's write example. I will call static method this compare, because I don't want to create so many variables with string, so many string variables. And let's say x equals to QString compare. The first one, let's make it equal, but with the different case. And here put case insensitive. So it should be equal. And let's QDebug x. And of course you can also, if your str equals to this, then you can make it that way. It works the same. But here I want to use static method to just not create so many variables with those strings. And now, if strings are equal, the result equals to 0. And in other cases we'll see right now, but let's test this case. As you see, it equals to 0. And let me make my space. Then next, let's say y equals to QString. Compare and put here just auto car, and it will be Qt case sensitive. So now this one is smaller than that, so we should have something bigger than 0. As you see. So in other cases, other than that, it returns a negative integer if first string is less than the second string, and a positive integer if first is greater than second. So we can also test the case if, for example, the same but case insensitive. So now we should get negative value, as you see here, because now this one is less than this in case insensitive format. And by the way, if it is unlogical to you why we have, for example, here uppercase and here lowercase, and it's like higher, it's bigger. As I said, comparison is based on the numeric Unicode values. Here I opened a Unicode character table, and as you see, firstly we have uppercase letters from 41 to 5A. Then and only then we have lowercase letters. So they are standing higher in this table. In ASCII, it's a bit different, so maybe it's unlogical to, but comparison is based on Unicode numerical values. Okay, next we have const begin. Here also we have const end. You know, they are the same as C begin and C end in STL. So, and they're also like here we saw already C begin. Yeah, we had C begin and C end. So they're the same. It is, we can say that const begin and const and are just equals to C begin and C end, and there exist these ones exist for STL compatibility, but work in the same way. So I think there's no sense to show example because you saw it already. Okay. Next, let's see. Const data. It's interesting one. It gives us read-only access to characters. This is the constant. So, for example, let's write const data. For example, I have str equals to hello, and then I want to get it. Char meaning that it's an constant array of characters. So const data. And then just to show you, let's iterate through that array and print it. So for in equals to 1, e as the necessary size. We have a size method just as in STL and I++. And I. Okay, let's see if it works. As you see, hello. And also, if I scroll down, we have this method data. It gives us not constant array of characters. So, you know, if you want to get this pure arrays, you can easily do it. Okay, and then contains. Okay, contains. This method helps us determine if the string contains another string or no. Also, we can use regular expressions, and also we can enable or disable case sensitivity. Okay, let's try. I will say that let's just we have hello, so use known by us method append, we used it, and append world, and that's all. Hello world. So let's, for example, if str contains rld, and then qdebug contains, and I want to here write, and I have to use the backslash, because otherwise I will get error, because the compiler don't know where string is end, where the end of the string. Str contain rl. Then let's test. I'll just copy and paste. For example, here we have hello, and let's also, just for clarity, qdebug our string, just to know what is inside. Hello world. Let's and also put qt case insensitive, and because we have here in small case, but it also says that the string contained, because we put case insensitive. And I also want to show you an example of how you can use regular expressions in Qt. But in next methods, I won't show you this, because you know, they are completely separated topic, and if you want, then you can dive into it later. But really, it is so much to explain if you're not familiar with it. So let me just show you the example. So here we have hello world and our string, and then we can create Q regular expression. Let's name it rare, and put here just to find it. And also let's include regular expression and regular expression match. Those types we want to use. And also I'll show you, we're gonna have a warning, and I'll fix it and explain why we have it. Q regular expression match. So we have our regular expression and match. Match. It's like container for strings that are matched. And let's say if str1 str contains our and we should provide match. As here we provide regular expression and pointer to match. Pointer, not link, as here. So because of that I use this operator. And if it contains, let's qdebug match, capture it, first one. We have here this warning, says don't create temporary Q regular expression object, you use static. And that means that we have to create it in static, because in most cases we create regular expression one time and then use it, and we don't want to recreate it. Okay, but I have some mistake, and yeah, here I should be here, because what be doing is use it to denote a word boundary, and we use this use this backslash just to use this one. It's like how the string works. If you want to use a double slash inside string, you should also give before that one. And this b thing ensures that the world is matched as a standalone word. And if I try it, I'll get world. And the next method we have here is count. And it provides us a way to count the number of occurrences of string in string. So, for example, let's write some example count and say is there equals to xo xo, and then let's count it. Count equals to str count xo x, because I want to show you one thing. Debug count. Here, as you see, we have 3. So let's count 1, 2. And as you can see, it also counts overlapping ones. So be careful with that. It counts it like that. 1, then 2, then 3. So with the overlapping. And it also have the case sensitivity and regular expressions. Let's use case sensitivity, for example, Qt case insensitive, and maybe let's add one more x at the end. We have 4, and the next ones are C begin and CR begin and CR end, and they're the same STL compatible iterators as before, but here we have reversed, and this means that you can traverse string from end to the beginning. This is that. So next is data. I mean, as I told you before, the same as const data, but here you can both read and write. And then and is obvious. You can get end iterator of the string. We talked about it earlier. Then ends with, and it's more interesting. It's used to determine whether a string ends with it or no. And let me show you an example. And with, for example, if str ends with x o and put here case insensitive, then we can QDebug contain. Oh no, ends with, not just contain, ends with. And as you see, no, because here we have it like that. So x like that, ends with. Okay, fine. And you also have method pretty similar to this. Let me find it. Starts with the same, but not from the end, but from the start. Okay. And where we here. Then we have arrays. Arrays, we can use it to remove some characters from different parts of the string, providing iterator pointer iterator that points to where to start and where to finish, or just single iterator to what character we want to delete. And let's try. It's str equals to abc d e f g h, and then str arrays from str begin, or let's use c begin. It's more likely we have to use here c begin because we have const iterator. We should provide it. Let's say +3 to move it 3 places ahead, and then strc and -2. And what we will get is QDebug string. As you see, we move it 3 places, so it's standing like here, and then to the end -2. So it's standing here. So from here to there, we remove DEF. And let's test also arrays. If we put, for example, str cbegin, only the beginning one, for this overload right here. And I think you know what we will get. Just remove a from the string. Let's move here we have fill. Fill doesn't have any overloads, and we use it to fill the full length of the string to the character we provide. For example, str fill, let's put a. So if I QDebug it, I have a because length is 4 and fills the full length of string with our character provided. Next one is first. We have two overloads, and it returns a string that contains the first n characters of this string. But don't use it if you are not sure the number you provide is less than the length. So let me show you what I mean. First, if I, for example, QDebug str first, I don't know, 2, it will work okay. I will get AA, as you see. But if I, for example, don't know how many characters inside, just in case, and put 20, I'll get error. Let's see. So in this case, if you're not sure if you're not sure the number you provide is less than the length, you have the separated method called left, and it here. Let me also test it quickly. Left. It won't throw you errors and just get a. And next method is index of, pretty important one. It returns the starting index of a string or character inside, and it search forward from index position from, so we can search for like next occurrences. Let me show you what I mean. index of, and let's say it's the name of some file, my text file.txt, and let's QDebug, just QDebug, str index of, and this match string. For example, let's search for txt. As see we have txt. Let's put here also. Here txt and here. So firstly, it will get us, let's see, this index 2. Yes, so the starting point, starting index of this internal string that matches. But we also can provide this from where we should start searching. For example, I'll put here 5. So it searches the 10th occurrence in this string, and that's pretty useful. The next one here, insert. It inserts a given string to a specified position and then returns the reference to the string with newly added characters inside. So we can write something like insert QDebug insert. I don't know. Let's put here. First, we have to put index, the position where we want to insert it, and then I don't know, some asterisks. And it returns us a reference to newly added characters inside. So if I just give debug string, I'll have the same as you see. It inserted us this string inside. Then we have is empty, is lower, is null, and so forth. It's pretty obvious what they are doing, and is empty and is null are similar, but the difference is visible when we compare a string with an empty string with no value at all. So what I mean by that? Here is empty, is null. For example, if I QDebug str is empty, what I will get? It's obvious that I will get false because we have some value here. But then I write str and put and assign to it empty string. And then what? I'll get true. But if I call str is null, QDebug it. I'll get false. Why? Because empty string is not the null. And if when we will get true is if I, for example, create null str, let's say it, and not assign it anything at all. And then if I QDebug null str is null, then I will get true. And that's why this exists. You see, I get true. And this last thing. Then we have is lower and then is upper. And it just checks if all characters are in lower or uppercase in the string, nothing more. Then is right to left. It checks if the text in string should be written from right to left based on its content, because in some languages we write from right to left, not from left to right, but reversed, like from right to left, and it just checks it mostly for displaying in parts and how we properly should display it in our GUI. Then we have is valid UTF-16. and it ensures that the string does not contain any invalid surrogate pairs of or invalid code points for UTF-16 encoding. It is pretty rarely that you have something invalid for UTF-16, but sometimes if you have to validate, you can do it with this method. And I have last and also first, where I don't remember if we covered first method. First, where it is here. Yeah, we covered it, and it works the same as first, just from the end. So as you remember, where we have it. First, yeah, here. It gets first values, some some number of first characters in string. But in our case, last, yeah, it works the same, but from the end. Then last index of works the same way as first index of. So first just index of, where index of, but from the end, exact same way. Then we have left, and yeah, I think I showed you before, but it returns a substring that contains n leftmost characters of the string, and the difference is that first, and the difference with this first method that I showed you before is that it won't throw an error if you give not valid argument. Just quickly, I will show one more time. Debug str, and we should assign it, or not, let's not assign. Okay, let's assign. I don't know, so maybe C. Here we go left 10. So it gets n leftmost characters from the string and not throw an error if you go out of scope. The next one we have here is left just filled, and it returns a string of a given size that contains this string packed by fill character. And if truncate is true and width is less than length of string, it will delete the remaining characters. Let me show it in the example. Left just field. So let's say we have something in our str. Let's maybe add more to it. Oh, no, it's good. Okay, let's say str equals to str left just field because it returns new string. And here provide width, I don't know, 5 instead of 3 that we have here. Then fill character, I don't know, asterisk, and truncate false, so we can leave it as default just. And let's see what we'll get. So as I said, it returns a string of given size that contains the string packed by the fill character. So you see, we provide this length, and if it is bigger than size of our string, then the remaining characters will be filled with this fill character. But in other case, if, for example, here we provide, I don't know, 2, what we'll get? Let's see. We'll get the same, and sometimes it you want this behavior, sometimes you don't. And because of that, we have this truncate false or true. By default, it's false, but here, if I specify true, and provided with is less than size, then string will be truncated to the specified size. Okay. The next method, length, you will use it all the time. I think you understand what it does. It just basically returns the length of string. And just to make it more interesting, let me also show you how to iterate over this string. So let's assign ABC, D, and then I can iterate over it. I'm less than str length, just constant value of, sorry, not constant value, it's constant method, returns as Q size type. I previously showed you there is pseudonym for other type. And here let's Qdebug I. Either we can use add method or str add method, or more frequently used curly braces operator, and get it by index. So we get A, B, C, D, E. So what do we have next? Local where compare, it's very similar to the compare one. It's not really important. Max size, it's also very abstract thing for mostly embedded devices. Than mid, it's more interesting ones. Interesting one. So let's see. Let me show you what it does. And mid is very similar to the method called first that we previously saw. But here you can provide from what index to start. I mean, here you have first, and you just start from the beginning. But in mid, you can specify from what index you want to start and where to end. I mean, it's not where to end, but rather just size of string you're getting. Let's say mid. And for example, here I have 2 and 2. CD, because see, we how these parameters are called position and n. So we put position to 2 and we start here, and then we go 1, 2. It's like the size of internal string we want to get. We're getting it. Okay. Then I have normalized. It's also not so rare, not very frequently used. Then prepend. Now, if you see, it has a bunch of overloads, mostly for the compatibility, but pretty important. I mean, pretty useful for them. Prepend. As the name suggests, it adds a new string or character to the starting of the string. So previously we just get the starting of the string, and now we can add to it something. Let's say, I don't know, 3 dots. Then we will get new one. Like this, we just prepend our string. Then what we have is pushback. Pushback is the same as append, just for the steel compatibility here. Push front, same as prepend. The same way, just for steel compatibility. And begin, we discussed it before. Then remove. Remove is more interesting because here you have 2 ways to remove something. First is specifying some string or character, and it deletes every occurrence inside your string, or you give index where to start and the count of characters you want to remove. And let's test it. So remove, for example, here I have the string, and for example I want to delete dots, or okay, let's just delete dots, and maybe here I will add a new one, so just to show you what I mean by every occurrence. So it's string, it's not like character, and it should delete all of that. As you see, it deletes every occurrence inside your string. And the second way is str remove. We give some starting index, let's say 1 here, and I don't know, 3 count of characters we want to delete. So we're left with AE because we start here 1, 2, 3, and left is AE. Fine. The next ones are similar. Remove add just removes at certain position. I mean, it's obvious. Then remove first and remove last is also pretty obvious. But one important thing, just so you know, remove first, remove last. Here, if you, for example, we have 2 characters, you remove first, then let's say remove last, and then one more time you remove first. And how do you think should we get error or not? But with this method, if string is empty, just nothing will happen and you don't get any errors. So it's useful sometimes. Let's go here. Repeated. So by the way, and the same as here, just for STL compatibility, reverse iterator to our string. Repeated. So repeat returns a copy of the string that has been repeated the specified number of times. For example, repeated. I say, for example, str equals to text, and I will add space, and then str repeated, let's say 3 times. Then I can QDebug it, because it just returns a new string. And if I have here text. Okay. Next one. Here you also have replace. Replace works similarly to that remove. I mean, the functionality is similar. You provide in similar values, but really it just not removes, but replaces those occurrences. So I think it's obvious what it does. Let's say, I don't know, a quick example. Still have here text. I want to str replace first I was specified before, so it's gonna be text, and I want to change it to maybe just char. Oh wait, yes, I can just throw here a char. It's just a character. What will get a, but here we have some logical mistake, because we assign text to it, then repeated it, but this the result of repeated method, we didn't save it to our string. So because of that, inside string we have only one text. So it is error returned. And if we want to fix it, let's just assign str to this repeated, and then QDebug on str. So let's see. Get a. Fine. Then the next method, reserve. It's pretty obvious, and you've not really use it. It just reserves some space and capacity of string. Then one of interesting ones, it's section. Uh, you frequently can have situations where you have to separate the string and then just get the section of it. And this is exactly what this method is for. So let me show you an example. Section. For example, I have str equals to some pass in our file system. It's a root, being the user's my file txt. For example, I have something like that. And then you want to get a section of it. So separate by slash and then get section of it. Most times most programmers will do is use something like split it to array, and then just get by index, or maybe instead of that, they will try to make loop, then check whatever it equals to slash, and so on and so forth. It's easier here if you know this method. You can just specify separator, okay, slash, and then put here start point and end point. Let's say first example, I get 1, so I get just bin, and you also can specify QString skip empty. You can section skip empty. You can skip or just leave it as default. Skip empty means that if you have something like that, it will not take empty one. Let's see what we got. As you see, we just get bin. And if you want to get bigger section, you can specify, for example, from 1 to 3. I'll get bin users my file txt. And it's really pretty useful and can save your much amount of time, not implement it by yourself. And then we got set num, and you'll use this method so many times, I promise you, because it converts number to string and has a bunch of overloads for different types of number. Let's see. Set num. For example, you have number 1, 2, 3, 4. And you want to str set num to num. So here you want to convert this integer to string and assign this new string to or str. After that, you can, for example, qdebug it and see it works. 1, 2, 3, 4 in our string. It's pretty useful, and you have a bunch of overloads for different types, also double float and so on. Then what is really interesting, simplified. Simplified is pretty interesting because it removes some symbols like simplified, and it removes everything like this, all those symbols inside string, and also white spaces. But not just white spaces, but I mean, if you have many white spaces, it will become just one white space, like simplify string. Okay, so let's try. Here, for example, put 2 white spaces, text, then /t, some other stuff, and then /r/n. But you want to just get your text with one white space between them. So you can use str simplified, it returns new string, and then if you could debug it, you see, it removes this, it removes also that and just put one space between instead of those all symbols. Then we have one of slice is pretty much the same as mid. So next we have split. Split is interesting one. As is, I talked about it when I written this example. What it does, split. It just splits our string and put it in the list of strings. So for example, we have 1, 2, 3, 4, and you want to separate them. So you can write QString list L equals to str split and by comma. And also, if you have something like this, for example, you can specify skip empty behavior. Then we don't have to write loop because we using the QDebug we can just make it like that. And we see 1, 2, 3, 4. It's so nice, I think. And then starts with works pretty much the same as end with. We talked about it earlier. Then what about the interesting ones? The interesting ones are this to int, to long, to lower, to short, to std string, to use short, and maybe to to upper. Probably to upper. Where is it? To upper. Yes, those are all to convert string to other things like number or std string, or maybe just to lowercase string or uppercase string. Let's test it quickly. So let's say to float, to std string, and so on. You can write, for example, str equals to 1, 1, 2, 3 point, and convert it to float. So if str equals to str to float. We also can specify here, as you see, okay. Here, interesting is base. I talked about it earlier in arg method, what is based and why we sometimes want to use it. fstr, and you'll get just float. Yes, or for example, str equals to, I don't know, abc, and you want to make it all uppercase. So let's qdebug and str to upper. The upper, and it's all uppercase. Maybe what is left for us, what interesting, maybe trimmed, sometimes useful if you str, for example, you have something like this and you want to remove not needed spaces from the beginning and end, you can just write trim it. And you see it removes all unnecessary spaces from the beginning and ending. Then you have operators, some static methods that you can read about. I think I showed you pretty much everything you need about this, about string. In the next episode, I think we'll make some small project or just discuss QStringView and QByteArray because this is also related to string. But I think it is it for today because this video is also pretty long right now. So thanks you for watching and I hope I will see you in the next episode. In this video you're going to learn about QLatin1String and QStringView. I will cover what are they, and the use cases when you will most likely use them. Let's start with QLatin1String. In the last episode, we discussed the QString class. And as you remember, it stores 16-bit Unicode characters. It means that every character inside QString takes us 2 bytes. Sometimes it is not bad, because our application may need it for language purposes. But in case we know that our string is also SC valid, we can save up memory using QLatin1String. ASCII characters take only 1 byte, but we're allowed to use fewer symbols, of course. Let me show you an example from the documentation. Here we have this function. I already have it in my editor, and I execute it. So as you see, we create a variable of type QString with some type, then compare it, is it equals, and if yes, then we just QDebug true. I also have to include QDebug header. And then we do the same, but with the QLatin1String. Let's execute it, see what we have. As you see, the results are the same. But it is all about performance. In the first condition, we compare our string with the C-style literals, const char. These literals implicitly converted to QString before comparison. Meanwhile, in the second condition, we make a temporary QLatin1String. This class is a lightweight read-only string wrapper for a USST Latin1 encoded string literal. Here it compares the QLatin1String object directly to the QString without converting it. Comparison is faster because it avoids memory allocation and leverages optimized Latin1 to UTF-16 comparison routines. It means that just makes it faster. Let's take a look at another example. Suppose you want to log some data and make it efficient. I'm making username, action, and ID just as variables. Let me paste it in my editor. Here, we make it just as variables, but it could be read from any other sources, of course. So, then I want to concatenate it and just log it to the console. In the first case, each literal is implicitly converted to a temporary QString. This one, and so on. Then I call to convert it to a number. To convert number to a string. When we use QLatin1String to wrap SC compatible literals, no memory is allocated, and we don't perform any UTF-16 conversion. But here, the concatenation involves memory allocation and UTF-16 conversion for each literal, each of them. In here, we don't do that. So it just makes it faster. And if you want to log large amounts of data and make it efficient, it is better to use this kind of logging system. So, as I said, in the first case, in this slower case, QString implicitly converts and allocates memory. And in the second case, no memory is allocated and it just works faster. To wrap up your knowledge, I made this table with the key differences between QString and QLatin1String. Here you have everything I have talked about. So encoding support, QString supports UTF-16, meanwhile QLatin1String SC. The memory usage 2 bytes per character, 1 byte per character. And performance is slower for ASCII strings and faster for ASCII strings because it uses it mainly, and here the QString is used for any other, I mean, all kinds of characters in all languages, just have more symbols that can store. And QString is making implicit conversion of literals. The next class we got here is QStringView. QStringView is a kind of manager for many strings. It references a contiguous portion of a UTF-16 string, but does not own it. So just as you see on this diagram, it can point on some portion of the string, but it not own it. So you can search here, you can extract some data, and that's all what you can do. But after you pass some string to QStringView, care must be taken to ensure your string lives longer than QStringView, and no references to deleted data are stored. Because as everything here, you should ensure the original string outlives the QStringView and prevent dangling references. This means that if, for example, QString goes out of scope and deleted, then QStringView should be also deleted, and it can't point on dangling pointers. And that is the thing that programmer should care about. The main use case for this class is as a function parameter type. Look at this example. Let's say we have a string in format key equals to some value, like this, and we want to make a function that helps us get this value. Earlier, we would do something like this you see right now. So let me copy and paste it to my editor. And let's also call it. And QtQuick, extract key, and I don't know, key equals to 1, 2, 3, 4, 5. Fine, let's see if it works. It works, we get 1, 2, 3, 4, 5. And because we don't want to make a string modifiable, I made it constant. And to prevent the string from being copied, we take only a reference to it. But see, here's a couple of problems. A function can accept only a few types of strings, only like this literal, and maybe if I QString still equals to, let's make the same, maybe now ABC, I can also pass it. But in case if I have something like, let's make the array of construct t, strc to new equals to, and let's put like key e equals 1, for example. If I want to pass something like this, I can do it. Of course, it's pointer. Yes. Pointer to this array of characters. And in case I want to call it with this, I can do it, because no mention function for call. I get error. And of course, finally, after testing everything, we have to delete it. Don't forget, if you make row strings like I had done here. And also, it's the first problem that I showed you. And the second problem is that function returns a new QString, which involves allocation and copying of the substring. So here, let's break down what is happening inside our function. We get in this starting string, so in our case it's key equals to. QString literal is just a macro to make string on compile time. Then we check if our string that is provided is starting with the key equals to. And if yes, then we return with the help of method meet that gets string from the starting point that we provide. In our case, it's the size of the start. It's 4 because we start from the this index, and then we continue to the end of the string, and we return it. And in this case, if we return a QString, then it involves allocation and copying of the substring, the substring we extracted. I want to show you how to deal with it and see that example. And this is another function that does the same thing, but with the QStringView. Let me copy and paste it. Here we have. I change name. It does pretty much the same thing, but only here it gets literal. It gets Unicode literal, then checks it starts with and return. And so the type that it has as parameter is QStringView, and return type is also QStringView. If I call it, for example, let's test the same things. From the start, let's name it 2, then 2, 2. And here we have to pass this Unicode literal. Then str2 also. And as you see, we can call whatever parameters pretty much we want, because now I will show you why. Let's call and see what we got. We have a problem. Oh, of course, yeah, because here I should, when I make this kind of string, we should pass the ending of it, so our code knows where the end is. And here we have it, everything is correctly. So the parameter is not marked as const, but we can't modify it. As here, for example, I write str append. I even can't write something like this. And the same applies to the QStringView. I can't write something like append or str, whatever method that modifies. There is just no. So we can modify it because QStringView doesn't own a string. Also, we not mark it as a reference. So it can accept all compatible types of strings pretty much, as I showed you here. And it's the list of these compatible strings is bigger. And the function also returns a QStringView, which is a lightweight view of the input string. So no new allocation or copying is performed. But of course, the color, in our case here, the color who calls method, who calls function like this, needs to manage the lifetime of the original string. And the QStringView is invalid if the original string is destroyed or goes out of scope, as I showed you, as I said you previously. So also, we not mark it as a reference, but it is not copied, because QStringView is just a reference by itself to the string. As I see here, I repeat it. Accept all QStringView compatible strings, no memory allocation or copying. It just returns a lightweight view, and function can't modify the string and doesn't need to create a new string. And I think this is it for today. I hope you enjoyed today's episode and the presentation that I made. I think firstly, the history of my channel helped you understand the topic better. In the next episode, we will start exploring QML and finally make some GUI. So don't miss out. Bye. This video is an introduction to QtQuick and GUI programming with Qt. I will start by clarifying the difference between QML, QtQuick, and Qt widgets. Then I will explain why I chose QtQuick over the Qt widgets for this series. And finally, we will write a few lines of code in QML language so that you will see your first self-made GUI. In the last videos, we explored the basics of Qt, but only with the console app. From now on, I want to make examples in UI, so that as the series goes on, you practice the skills of making user interfaces with new tools. I just want you to use Qt core functionality together with QtQuick. Let's start by answering the following question. What is QML? QML, by the way, it means Qt modeling language. is a declarative programming language designed to define user interfaces. Declarative means that it focuses on the goal, in this case describing what the UI should look like and how it behaves, rather than how the goal should be achieved. Uh, JavaScript is the subset of the language, so you can add logic and interactivity to your QML components. If you're familiar with JS, there won't be any problems with starting to write QML code. Let's explore an example of QML usage. The code consists of two key items, rectangle and text. Each item has its own set of properties inside, for example, width, height, text, etc. And here's how it looks like, you see. This example demonstrates how the structure of QML language looks like, and additionally, QML allows you to define signals and slots to integrate JS, adding interactivity and functionality. So as you see here, you have some items, for example, a rectangle. Well, you know what what rectangle is, and have some properties, for example, width, height, color, and so on, so on. So it means the declarative language, like you declare what you want to see. QML language is used with QtQuick. So what is that, and how are they related? QtQuick is the UI framework that powers QML. It provides a rich set of tools for building UIs, and it works nicely with embedded and mobile platforms also. QtQuick is easy to style, customize, and animate, and that's great. Look at the previous example, okay? As I said before, rectangle and text are items that help you build your UI. But these items are really coming from QtQuick. And firstly, you should import QtQuick in your code in order to use them. The conclusion comes out of this is that QML is a module that provides engine and language infrastructure. Meanwhile, the QtQuick module provides all the basic types necessary for creating user interfaces with QML. With the help of QtQuick types, you can create and animate visual components, receive user input, and just build modern UI. See here, you have a bunch of items that you can add to your QML code. Think of QML and QtQuick like this. QML is the script you write to describe the UI. It's like HTML on web page or the blueprint, you know. And QtQuick is the library that provides the actual elements and functionality. It's like CSS and JS frameworks in web development, or just toolbox and materials. By the way, you can also create your own items. Technically, self-defined items were created using QML, but powered by QtQuick. And it is also possible to make items using C++. And in most cases, it's a preferable option. And I will show you in more details about that in later episodes, so don't worry, and we'll make our components with QML, we'll make our items with C++, and you will see how it's done. And then it is also possible to integrate those items from C++, for example, or some data from C++ to the QML. And that is great, you can later use this in your QtQuick items. And now see, there are really two ways of building GUI in Qt. First is QtQuick, and as you see here, examples of application made with those two ways. QtQuick is modern, customizable tool with many features, and it is better for big and custom projects. Meanwhile, Qt widgets, it's older, hard to customize, but the main advantage is that it comes with many items that look natively for the desktop platforms. So you don't need to write a lot of code to make your application look natively for all platforms, and you have many like components, many items to use inside. And now we have the third element of today's topic, Qt widgets. What is it? And why did I choose QtQuick for the series? Qt widgets provides a set of UI elements to create classic desktop-style user interfaces. It is an older way to make GUIs on a desktop. Using this approach, we get plenty of controls that are adjusted to different platforms to look natively. Mostly, widgets are general, and many things have been already coded for you. But this approach also has such disadvantages as difficulty in styling and animating, is horrible looking widgets on mobile platforms, and less opportunities to make something unique rather than just classical looking application. When you develop applications with Qt widgets, you don't use anything like QML. The code is written in C++, and the visual part is done with the Qt Widgets Designer, which uses what you see is what you get, or simply receive approach. To summarize the difference between QtQuick and Qt Widgets, I have this table. So QtQuick is easy and flexible in styling, rich and customizable animation, platforms embedded and mobile, and also desktop. Here, I mean, embedded and mobile is possible. And language used is QML. Qt widgets are hard to style, it's limited in animation. Platforms, in most scenarios, you'll use it only on desktop. There probably, I mean, there are chances you can use it on embedded on mobile, but rather just on desktop. And language used is C++. And like understand it right, because in QtQuick you like also use C++ to define something, but in Qt widgets like you make everything with also this structure that I showed you earlier in QML when you write some items. When you use QtQuick, you separate your parts and you can create, for example, your items, some custom items in C++ and provide them in QtQuick. But in Qt widgets, you make everything in C++. I will use QtQuick in series because it is more modern and gives us more flexibility. Nowadays, most companies that are using or starting to use Qt prefer QtQuick. Now let's create your first GUI app with Qt. As always, go ahead, click at Create Project, then select QtQuick application, because earlier you selected Qt console, now Qt quick application. Choose, title it something, I'll name it video, as always. Next, next, finish. You're going to see the default code generated for you in the in QML. Delete this input panel because we don't want it right now. We now want something more simple. And you also can delete this import. And for this basic structure, it's just a window. And if you run the application, but sorry, now I increased the scale. If you run the application, you can see, now you'll see the window with a width of 640 pixels and height 480 pixels. And the title, Hello World. Everything you see is defined in your code. And that is the beauty of declarative language. And now let's quickly go through the project structure, because we have a slightly different configuration in CMake list from the previous one with the console app. And there is also a new code in the main to display UI. See here, you have some another stuff, and in main you also have some new code made for you. And I opened two projects. Is one from the previous tutorial. It's console app and our here. So I will just compare CMake lists file. In console app, for example, let's start here. We used find a package here with the core, but in the new application here we also use it. We include like finding package quick, but it implicitly includes the core module as well, and we don't need to find those two packages because it just implicitly imports also the core. If you take a look at documentation, here you see what modules we have. They're essential ones, so you see. For example, we have Qt Core, QtQML, QtQuick, QtGUI, and so on. So let's add some comment so you remember. By the way, in CMake you make comments like this, like in Python. Implicitly includes the core module. And then there's also some unknown for us call to function Qt standard project setup. What it does, it's here, as you see the difference, here you have something like this to enable mock and to set some properties. And really what it does, it sets those all variables for us, and it also makes a couple of other configurations, so don't replace it with what you have in your console app. Don't replace it. I mean, it will work, but in the long term it will cause you some problems because it also configures some things related to files, and all this includes stuff. So it just helps to configure your project. Despite add Qt add executable, because here you have only Qt, only Qt, not Qt, but just add executable. Despite that, you also have a Qt add QML module. This command defines a QML module that can consist of, for example, C++ sources, QML files, media files, and many other stuff that we will use in later episodes. And then after you add it here, you can use it in your QML code. So if you want to drop some image in your code to make it visible in GUI, you probably gonna need to add it here with this command and then use it with QML. And then set target properties. Set some properties on a specified target to affect how it gets built on different platforms. So let's also comment affect how it gets built on different platforms. And for example, just you set something that is neat for macOS, for Windows, and so on. You can find in documentation what every property mean and how it affects the process of building different application for different platforms. I want to close it, okay, because I don't need this console app application from previous episode. And in main CPP, you also got this new chunk of code. And let's break down this step by step what is happening here. So firstly, the QML, also here you have includes, of course, and QML application engine is used to load and manage QML components in your application. For example, as you made here. And it also, if you want to, I don't know, integrate some C++ code to QML, you will also need to use it, okay? And then we are setting up a signal slot connection for error handling. The signal here, object creation failed, is as you probably guess, emitted if the engine fails to create the root QML object. For example, due to missing files or errors in your QML code. We provide lambda in the slot. Here we have a lambda function that exits with the code -1 if creation is failed from the application, setting up a signal slot connection for error handling. And then we have engine load module and name of our project and main. Here we also have main QML file. And by the way, Qt connection is used for thread safety. We'll talk about it in later episodes about multi-threaded applications, but now just know that it used for thread safety. Let's also add it somewhere. It's used for thread safety. And finally, as I said, we have this loading. This method loads a QML module that was registered previously. Here we registered QML files, main QML, and now we can use it in this method. Method loads a QML module, name it tutorial 7 video, and searches for a QML file named the main QML within that module. If the main QML is found and successfully loaded, its root object becomes the main UI of the application. So let's QML module. We will now write a minimal app that displays a welcome message and a button. Clicking the button changes the message, this one, hello world, to something else. Of course, full code is in the GitHub repository, link in the description below. You can take a look or download and whatever. Let's go to the editor. First of all, let's go to main QML, change the identifier window to root because it is more convenient name for this element, and I also want to change this hello world to welcome app without this function we used before, QStr. Because this function is used for internationalization, and for now it is not important for us because we write just simple application. Then let's make this text you saw on the top. I will just copy and paste and not take your time because in previous episodes I coded everything, live coded, but I think if I just paste small chunks of code, it would be faster and I won't just spend your time on my writing. So here what we have, text, just welcome to QtQuick. I made the font bigger and provide pixel size 24. To locate the item on the window, we use anchors, these anchors. In this case, I am taking the horizontal center and the top position from the root and shift it in text on 20 pixels to the bottom. So here, as a horizontal center, where its center of my element is text, I take parent, this means like this root, and the horizontal center from it. So my text will be at the horizontal center of the window. Then as the top, I also take parent top, so my text gonna be on the top of the window and on the center. And then I make this margin 20 pixels, so it is not just right on the top, but have some margin also. Let's see, save all. Let's see what how it looks like. And you see, as I said, horizontal center, top of the window, and small margin so it looks more beautiful. Fine. The next text item is the one that will be changed later. So I also added here an ID to it. Welcome message. We provide ID because later when button will be clicked, we're gonna change this. So we got to find this item. For example, here I used parent, but I can also use root. Okay, there's no problem. But when you can use parent. Okay, then text hello world, default one. Make pixel size. Make font size a bit bigger, and I'd center it in the parent. As you see, I didn't use horizontal center or something. I just center in because we wanted to put on right on the center of our window. Here we have it. Fine. And the button on the bottom of the page is located similarly to the top text, but with the margin from the bottom. So let me copy and paste it just. Here we have rectangle. There is no really such thing as button here, so you just make rectangle. But it is easy to style, don't worry, it's not some cumbersome stuff. So here you have rectangle, and imagine that this is just a button. I'll show you how you can handle on click event. So width, yeah, I set width, height, color, border radius, so our border is gonna be like rounded. Center it on horizontal, then put it to the bottom and make some margin from the bottom. If you take a look, I have this kind of button. Then I also want to add some text inside it. Of course, I can nest my items, and here text, click me, color, and center in parent. In this case, parent gonna be rectangle, not the window. Okay. I mean, if you are familiar with CSS and like with a little bit web development, it won't be any problem for you. And here we have click me, but if I click, nothing is happened. So I have to add event. Also inside a rectangle, I add mouse area. Mouse area just helps us to make some events with the click. It can be on clicked, on hover, and someone will explore more later. Uncross fill parent, it just means that this item fills all the rectangle, full rectangle. And on clicked, as you see, the code inside unclicked event is just JavaScript, and we just provide this method. I mean, not method, what we're making when someone clicks it. And on clicked, let's say if you got click me, if I click, you click the button, fine. And you can do something with on hover and so on. Just to show you that it is just JavaScript, I can write something like this. Console log click. And now look at the application output. If I click, here I also have a message from the QML, click, click, click. So console log just outputs it in our application output. As you see, it is not hard to implement this kind of application. It was pretty easy. I just used QtQuick items, and you can build bigger and bigger applications. Okay, to wrap up your knowledge, QML and QtQuick simplify modern UI development. QtQuick offers flexibility and animations, and we'll explore, of course, more advanced features in upcoming episode. Okay, and I think this is it for today. Thanks you for watching, and I hope you like this introduction to QML and QtQuick. So see you in the next episode. Thanks you for watching. In this video, I will show you all the possible ways to integrate your C++ code into QML. Then I will explain the pros and cons of every method. And finally, we will make this simple app using both C++ and QML that will filter and display logs in the file provided by the user. But what does integration gives to us? As developers, we always care about the performance and extensibility of our applications. QML and C++ integration gives us the ability to separate logic. So QML handles user interaction and the visual part, and C++ handles the logic. Uses data models and can call, for example, third-party libraries like Windows API. Now I will make a logs filter application and then show you all the ways to integrate it with C++. If you're not interested in coding UI and C++ class that will be later integrated and just want to see the just the integration part, go to the next section with the context properties, and you can get the full code for free from the GitHub repository, link in the description below. Our application will read logs from that kind of text file where a type prepends a log message. For me, it was just ChatGPT generated. Here you have type of log for info, warning, error, and so on, and just the log that will be displayed. And our application will read that kind of file and display it and filter it and display only needed logs. I already created my project for today's episode, and now let's make a new class. As always, create new class and call it logs filter. It's gonna be like a backend for our UI. It must be QObject in case we want to integrate it with QML. You must specify it as QObject. Next, you know how to do it. Create your class, and in the header file we will have three properties: file path, filtered logs, and file name. The file name will be derived from the path, so I will only make a getter for it. And now let's just copy and paste so I don't spend your time. In the private section, let's make two QStrings. And so both stored properties are of type QString, but logs can be made with the QString list because it is just the list of logs. But I use string for the simplicity. Okay. And as I said, we're gonna have one more property as a Q property. I will show you later what it is with the file name. Because as you remember in our presentation, here no file chosen, then for the file name will be displayed here and in this field. Qt provides us a property system for QObject to simplify a way of making properties with all needed things such as getters, setters, and etc. So all you can do is here add this macro provided by Qt. It makes property reactive, so it will call. So QML will call getter every time value gets changed, and make data valid in UI. You'll see more clearly why we use it when we will integrate this code with QML. But for now, as you see, here we can specify in EAQ property just our property, then access point to read it, to write. It's like it's gonna be just getter and setter, and notify is just a signal when this property is changed. So it's just, for example, if I will expose this property in my QML and in C++ emit this signal, then it will automatically be changed. So my getter will automatically be called after I change my property, and I don't have to bind my signal to some slot to call every time some getter. Everything QML makes everything for us, and when we will make UI, you will see more clearly with the example what I mean. Despite the thing that Q property gives us auto signal notifications, as I said, if it means that when we emit a signal in a notify, the property will automatically update it in QML. It also gives us meta object support and simply readability. It's just conventional to register properties like this in Qt. And now we should define everything needed for properties. So let's start with the get file name. It will be getter for our file name here. I make it constant const because value returned is constant and we don't change anything inside our method. Then we need to make getters for filtered logs and file paths. As you see, names are the same, but this is getter, this is method. And I just return my property. M filtered logs and M file name. By the way, M means member. If you never heard of it, M means member. And then setter for the file path, and notice that file path is the only property that has setter inside. So we set some new file path, and in the signals we make 3 signals for each property we have, and then we will emit it. For example, in the file path setter, we're gonna emit file path changed and file name changed, because as I said before, file name is not stored here. It just derives from file path. We'll extract from file path our file name. So we'll call those two in the setter. We also need a method for actual log searching by the type. So let's add it, for example, here. Here we search logs with the type provided, as I showed you before, text file. And to make methods available in the QML, you can either edit a slot specifier, so edit public slots, or add the QInvocable macro. The difference between those two ways is just metadata. Functionality will work the same way, and but as you see, I didn't market getters, these getters and setters, as QInvocable, but they are available in QML calling them, and the reason for that is that Qt will call them implicitly. So in Qt, I will, for example, write it something like maybe my object file path without braces, or file path equals to something without actually calling it. And Qt makes everything implicitly for me. But in this case, we'll execute this method when the button to search logs is pressed. So we have to make it QInvocable. So to make it available in our QML. Let me quickly show you the ready application just so you understand how it works and you understand the logic to easily implement it later. The application will have a button to select file. When you click it, the dialog window opens and choosing a desired file is getting the name of it displayed. As you see here. As you remember, we have a property for file path and property with a getter to get the name of it. And file actually stored is only file path. The next input is the drop-down list where the user can choose what type of logs he wants to be displayed. And for example, I select warnings. Then we have a button to search results in the chosen file. After clicking it, our application opens a file, reads data from it, and displays only the rows marked with the keyword for the selected type. As you see here, we get results from our text file. And I hope you understand the logic. So when we change something here, we change path property. When we change something here, it is stored in QML, and then when we click our button to search, we just provide this type that was chosen by user in the drop-down list, and it automatically displays these filtered logs in text area at the bottom. Now let's implement method we created earlier. First of all, for the file path, but okay, let's firstly refactor and implement everything. We here have set file path, get file name, and search logs. Okay. We have warning, but don't worry for now. And let's first of all make a setter for the file path. Here I want to use QURL and we can include it. Well, let's make it in our header file. Include QURL. I use QURL here because by default we get kind of path like here, like this, by default, with this prefix file and slash. But we don't want that file prefix, so QURL just gets us an absolute path. QURL is a convenient interface for working with the URLs and also paths. We could also just use some string method for removing the first characters. As you remember from the previous episodes, there is some kind of methods just to remove certain amount of characters at the beginning of string. But I wanted to show you this class and this functionality. After extracting the path, I check if it differentiates from the previous one, because if the path stays the same, there is no sense in changing data in UI. And as you remember, when we emitting something here, it also changes in UI. If paths are different, I assign a new one here and emit a signal. So the QML part can handle it and update the displaying data. I also emit signal for the file name because as path changed, the name is also changed in most cases. The next method to implement is getter for file name, and it is more interesting one because we have to here validate the path property. Okay, let's also include QFileInfo and I'll explain you what it does, of course. Okay, here, first of all, I should validate my file path property. For a response, if it is empty, if we don't have any pass, then I use QLatin1String, and if you don't know the purpose of it, then you can watch my video in the Qt playlist about the string view and Latin1String, and you can understand why I use it here for this kind of response. Because as you remember from our application, if the pass is empty, I don't leave my field near the button as empty, but I just write this message that no file is chosen. Then I use QFileInfo. Is an OS independent API to retrieve information about files. So you have so many informations inside. As you have so many methods that you can use. In our case, we're just checking if it exists or not, because we don't want to later read not existing file. And if it don't exist, we return this message. And if all validations passed, we return the file name. So also to get file name, we can use this class and here we have file name, file path, file time, and so on. And this also interesting class. The method for searching logs is going to be the longest one probably. If you are familiar with the C++ way of reading files, there won't be any problem for you to understand what is happening here, because it is pretty similar to just C++ way of reading files. First of all, we validate the path is empty or not. Then we try to open the file in read-only text format, and here the binary or operator is used to unite all parameters. I think you remember it from just some C++ tutorial. If opening file didn't succeed, we just stop the execution. After the file is opened and everything is okay, we can clear the previously found logs and reserve some space to not make a reallocation when we read data. Qt stream provides a convenient interface for reading and writing text. We already used it in the first episode, but for the console. So here, until we don't reach the end of the file, we extract text line by line to the string view. Yeah, until we don't reach the end, we provide line by line in string view. If you don't know what QStringView is and what is the purpose of using it rather than just QString, I highly recommend you to watch my video about it, about QStringView, and also I covered there QLatin1String. We check if the extracted line starts with the desired type of logs, and if so, we get a log without the type, with the method mid. So here, if you don't understand how this works, then for example, you have this line, info, some text. If you start with type, for example, our type is info, then here I get the length of this type. In our case, this is gonna be 4. And then +2, +1, this semicolon, and 2 is the space. So I get this size from the start, and I just extract everything after it, afterwards, this info thing. And I extract my message from the log to this clear line QString view. Then we append the parsed string to the final result, and I also append it with the new line because, as I said, it is possible to use QString list, but QString is used here just for the simplicity, and so we can easily display it just in the text area. After everything was parsed, we have to close file and emit a signal informing QML that logs were changed. So we can just file close and emit that something was changed, and you have to update data. We should say it to our QML. And also don't forget to initialize the file path in the constructor. Here we can do it because the string can be empty or null. And if you don't know what I'm talking about and what is the difference about empty and null, I highly recommend you to watch my video that is named like everything about QString. It's a pretty decent video about QString and Qt. I recommend you to watch it. We are now finished with the C++ part, and the next task is to make UI. I want to tell you just from the start that it is possible to separate things into different files in QML, but today for the simplicity I will work only in main file. Let's firstly delete everything we have here, and let's start with the imports. Okay, so QtQuick, we imported it earlier, just controls, the basic ones. Then Qt dialogs will be used for file picking dialog window. Let me write comment here, file picking dialog window. Then Qt layouts, used to arrange items in AI. Arrange items in UI, and I will mostly use column layout for vertical alignment and row layout for horizontal alignment. It is not something complicated that you should worry about, so you will see as I will do it. And then Qt controls, I use it for things like buttons and drop-down list. As you remember, we have a drop-down list, and to not implement it from the scratch, and the same with the buttons, we will use this module. And of course, it is possible to make custom ones, but this is really another topic. And Qt controls material just for the beauty of our applications, of application, and it adds good looking cross-platform styles for our controls. As I saw in video, it looks like okay, and this is thanks to material module. Okay, in the window item, let me create it here. In the window item, I make one column layout that will fill the full window and make margins from all sides. I fill it and make margins, and spacing is just spacing between childs inside this layout. This is property used only in the layouts. Inside it, let's make a group box. Here, group box for our form. It will also add this thin line, as you remember, around inputs. Notice also that when you use layout, you align items inside the layout property instead of anchors. But the naming is similar, so it is not really a problem. As you see, here I used anchors because the parent is not some layout, but in Groupbox I use layout for the align items, and here I use layout property. Okay. Then inside Groupbox there is also a need for spacing. So let me create column view for items inside. Here we have it. Inside group box, we're gonna have like column that will represent like the box for the inputs for this file input and for the drop down list. And inside first row layout, we're going to have a label, a place for writing the file name on or the place for writing the file name or the message about the lack of it, because as you remember here, now you can have this kind of message or just the name. And a button for opening dialog. File dialog is not something we see when we just run the application. We open it as the button is clicked. So let me paste it here. Yes, it's okay. I think I didn't mess up curly braces. Just yes, yeah, I think it's okay. So okay, we have a row layout inside the label, the text, then text field with the some file name. We will later bind it to our property. As we make the integration part, we'll bind it to this property. And then we have button to open dialog, and on click is just like event we open in our file dialog with the ID. Here inside file dialog, when user selects some file, we get this event on accepted, and we can get the path to selected file that we'll later put here into our setter, the file path. But for now, I just console log it so you see what we get. And the next row layout gonna be a little bit smaller. It will contain only the label and combo box. Sorry. The label and combo box. As you see, we have a label, so we know what so user knows what you have to give us, and combo box is just drop down list coming from the Qt6 controls. And here we specify available options, info, error, and warning, and layout field with true. Okay, under the group box we'll have a search button. So here we have our group box, we can hide it, and under it, under group box we're gonna have button to search logs. Inside it, when the user clicks our button, I get this current text from the combo box we made earlier. This current text is just option. Let me show you here. As you remember, here we have this combo box with the model, and current text is just the selected one of those three texts. And material background is just used because here we use this module, and now to change some color we need to use material property instead of just default one. And at the bottom we going to have a space for logs. All space that is left is gonna be needed just for displaying logs. I will make it like this. Okay, some mess with the curly braces. Okay, I hope that is fine. So I make rectangle that just fills everything, fill layout, taking all the remaining space. Clip flag is used to hide elements underneath while scrolling. It is basically recommended when you have some list. As you remember, as you probably understand, logs can be pretty long, and clip just makes it available to comfortably scroll it and not have problems. So it is just hiding underneath all elements that is not needed to show to us. I'll show you what it means in a second. So the flickable item wrapper gives us use the ability to tap and hold the list. So you can like type, hold, and scroll. So if you're going to have large numbers of logs, it is like easy to scroll them with this thing. And the text edit is a place for filtered logs, and the word wrap means that wrapping is done on word boundaries only. So it can go to the second line if it needs. And okay, I think this is it. Let's check what we have. As you see here, everything that we made. As you see, I specified some default text. Later I will remove it, but just now so you see what is happening. And I can select some file, search logs. Now, and as you see, when I click search logs, I console log what the thing that I got here. So now I get message, info, or warning, or error at the same with the select file. Let's select, I don't know, I have some random file, and here I have full pass. As I said you before, we got this file thing that will be removed in our setter. And here we also got it in, I don't know if you see it, I hope you see it, but we have it in our output. Now it is time to integrate our C++ class with QML UI. As you have like 3 ways of integrating. Most popular ones is context properties, singletons, and instantiable QML type. I will show you all of them. And let's start with the context properties, or they are frequently also named as or embedding objects into QML. It is the simplest one, and we'll start with the simplest one, and in the end we'll use the most recommended method. Okay, the first way of passing C++ object into QML is with context properties. I want to immediately warn you that this approach is not recommended because you can't really keep track of your objects. And now we will go to the editor and I will show you what I mean by that. Okay, let's make a simple example for the start. In the main function, we can just get root context from the engine. So from the engine, we can just copy, we could just get root context. It's just context for the whole application, and set the context property with the name and value. Okay, and you also have to import this root context because the type QML context, so the compiler knows what is the lane inside. And the very important thing, that set context properties before the load in main module. So you need to set all your properties before this loads, before this line of code, because otherwise you will get reference error while calling it in the QML. I mean, it will work, but you will get error, and it is not great. So here you also need to do that before loading from module, because you will use it in the QML, and from the, like, you need to start with the loading it, and only then open your QML. I think it's logically understandable. And by the way, QML context, this one root context, is a holder for the objects identified by ID in a QML document, really. So it's just holding those items that we added ID in QML. The root context is automatically created when by the engine, and the data we provide is available everywhere in QML. So in QML, without any imports or something, we can do it here before everything, just to test. We can add text with my message. As you remember, this is name we specified here, and just let's run it and see what we got. If you run the application here, it's in at the center, not really beautiful, but it doesn't matter. You'll see everything working. As I said before, it is not a recommended way of integration. The reason for that is that is maybe unclear from where it comes from for someone reading QML code, and it limits their usability, since the context may be different in other places where it might be used. So I mean, if you have large application and you have those contexts that's everywhere, sorry, it may be really not clear from where data comes from. So it is not really recommended way of integrating. But we are here not to just show some message. Now let's pass the previously created logs filter class to the context. I mean the object that we will create. When you want to expose an instance of the object allocated before the engine to ensure that the instance outlives it. So I will use here QScope pointer as recommended in documentation, with the templates included. Include the logs filter, and here let me just copy and paste. Okay, so one by one I create QScope pointer to avoid the headache with the pointer, to not delete it and think about it. It just manages everything for me, and I have to create it before the engine to make sure it outlives engine. And if you're not familiar with smart pointers, I highly recommend you to watch my video about it, where I discussed all kinds of smart pointers in Qt. Okay, and then I create my object, my logs filter, and then I create engine, and inside engine I said let's make this name, so it will help us. Okay, and I just said that with this key value our object get in object inside pointer, and now using this keyword we can make some changes in QML. Let's start from the beginning here when we wrote some strange data, just so it be. First thing, it's a text field. Here inside text field we should add it and call file name. As you remember, here we specified property file name. It have this name. Then in the file dialog, instead of outputting it to the console, we can call the file path setter, which is also emitting the file path changed signal. So remember. So here file path equals to file path, this variable. Fine. If I run application, just to show you, if I select some file, I found this file I previously created with logs. When I edit, I get here name of the file, logs.txt, inside this text field. And as you understand, everything works. Our signals and slot works, because as you remember, I just here specified my name of the property without calling getters, without something. I mean, it called getters underneath, but I am not writing this logic by myself. And see, no files chosen. I select some file, and it updates. So fine, our path is also updating, and here when I using equals equal sign operator, then my setter is called. So here my setter, this one is called because I specified in file path write to the set file path setter. Okay, when the search button is clicked, we should call also a method for searching with the given parameter from the combo box. So logs filter, search logs, and we give here one of those three options. As you remember, here we got this type thing, and there is method that we are calling, and it's also specified as QInvocable, so it is available in our QML. And also let's change text edit content from logs here to filtered logs. Okay, if we run the application, as you see, everything is working. For example, we select error, warning, and so on. And by the way, I didn't really properly explain what clip is about, but as if you tap and hold, you can scroll. And you see this text is underneath other components. So that is what clip does. So when you scroll, it is underneath other components and just uses this box, this text area that have. So it's all about this. So okay, I select file and I can search some logs, and it works fine. Just to wrap up, content properties could be okay for some global static values, but we have better options for this kind of stuff we have today, this kind of program. And the next thing is singletons. First of all, let's clarify what singleton is in the programming context. Singleton is a creational design pattern that ensures a class has only one instance while providing a global access point. It's just definition from the internet, from the Wikipedia or something. I mean, really, you like have your class and you create only one object, and you make sure that this object is really one created for all application. And the main ways to expose singletons to QML are imperative, and this is older type registration using the functions provided by Qt, like QML register singleton type or singleton instance. But the imperative type registration is an older way of providing singletons. The major disadvantages of this approach is the impossibility of extracting necessary information about the module at compile time. So it is too unfriendly. And it means that just you won't get any hints inside your QML because it is not possible to define what properties you have at compile time while using this imperative approach. And also, if you use this approach in large applications, there will be big chunk of code just repeatedly registering all classes and instances. I mean, you'll just call these functions one by one, registering everything, and it's not really beautiful in big applications. But it is still frequently used, so I will show you how to use it also. And registering a class with certain macros to provide singletons. It is possible with the Qt6 or higher, and I really like this approach. You just add some macros to your class. You don't need to write anything inside your main function, and it is really great because you add macros and you have your singleton inside QML. You can use it. I will certainly show you this method after the imperative one. Okay, so how it looks like in code. So we have our main. Let me just comment this out and write that it is context properties, and now we use first of the singletons approach. And here, as before, we create our object as a smart pointer, then create engine, and then we, with the help of this function, we're registering the instance, not the type, because we can register the type or we can register the instance. When we create some object and then register it, we use this instance thing. The first parameter here is the URL of the module that will be that you will import later in the QML. So you're gonna need to like import it the same way as this imports. Okay, then you pass the major and minor versions of your module, and finally you pass a name that will be used to call your object in QML. Let's also make it with the small L letter to not change anything inside. And you specify pointer to like object that you want to use. And now we can go to main QML and add this import. So we import our module and add also versions. It is not required to add versions, but just good practice to add. And let's run. Oh, we have some error. Oh, whoa. Oh, yeah, okay. We should change it to big letter. And now let's... Okay, sorry for that, but we don't have really a lot of code here, so we can, I think, easily replace just all uses of logs filter to the capital letter. And now let's check it if it works. Yeah, it works, and we can select our file and then select, for example, error, and let's see what logs we have. And that works pretty nice. But if you go here and write logs filter, then dot, as you see, you don't have any hints. So it would be really great if editor writes for us that we have like search the logs method or some another property. But as you see, editor don't give us any hints. And this is an example of tooling of unfriendliness I told you before. Okay, let's now take a look at registering types instead of instances. So here I registered the instance, but we can also make registered types. When you register types, Qt doesn't care, it doesn't create an instance for you. Instead, you provide a callback that returns the instance of your object and ensures that it is single, to not violate the singleton rule. Inside the logs filter class, we can add method that will return an instance. So here we should include QML engine, because the method that is used to create instance, this callback, is taking some parameters coming from this header. So in here, let's just edit. So it is static method to get the instance of our class, and this method, and we should make sure that the instance gonna be single in our program. And really, the implementation of method gonna be really easy. So if I go here, make it like this. So we specify our static static member inside class to store this single object, this single logs filter object, and then inside the instance method we just check if it exists. If it don't exist, we create a new one, and if it don't exist, if it don't exist, we create new one. If it exists, then we just return the one that is already here. So it just makes sure that in our program we have only one instance of logs filter. And then inside main, let me also comment it, and now we can make something like this. We create engine, then we registering our type. Here we registered with registered instance with this function. Now we're registering type with the type logs filter, specify name for the module, version, the key to later call it, and we provide here the callback function. This callback function will be called to create our object. Also here I didn't told you probably that what those parameters are. And our method takes this QML engine and QGIS engine mostly for historical reasons. So I don't even provide a name for those parameters because I don't use it. And probably there is gonna be a moment where you need to use it, but in our case, there's no sense to even give the names for them. And now, if the names are the same. It's also my import logs filter. So now, if we run application, everything should work just fine. But now, just Qt creates for us the instance of our object. Now, if I select logs, and as you see, everything works. Okay. The last, simplest, the most recommended, and just my favorite way of defining singletons is with default constructible class and QML singleton and QML element macros. With Qt6, this way was improved, and now we need to neither register it in the main or CMake. So we make everything inside our class, and we don't have to change anything inside CMake or main function. Okay. Here in our class, we should first of all include this header. It contains the macros that we need right now, and we can add macros QML singleton and QML element. This will register the class by the same name in the QML module file belongs to. Okay, QML element. This macro registers class as an instantiable QML object type, and QML singleton provides that singleton functionality where you have only one object. So okay, this one registers object inside the QML, and this one makes sure it is single, and we will access it by the same name as we have in our class. We can change it, and I will show you how. Now let's go to the CMake lists. We don't need to change anything here, but we need to take this URI because, as I said, this will register the class by the same name in the QML module file belongs to. So we have this module and our file belongs to this one. So we need to copy and import it. And if we just try to execute it without really changing... oh, no, sorry. I forgot to comment it. No, it's commented, and now we're using really the method with this macros. And if we try to select some file, everything works fine. It's already fine because we just added two macros and we don't need to do anything more. But the important thing to mention is that you can rename your class with the QML named element. Here you can specify this macro, and you will access not with the name logs filter, but with the name other name. We won't use it for now. Also, if you don't have a default constructor, this one with just one parameter parent, then you have to define a static create method. And let's say I want to receive a file pass at the construction step. So, for example, I have my constructor, but I want to modify it and receive also pass. And here the same, we need to modify it. And now we just passing our pass here to mfile pass. Okay, fine. And also here we got problem. It is not really important for now with it because we don't use it method. We can just comment it. But if you want to use it, you just add in here inside some value. It is not really hard to do. And if you run it with this modified constructor, let's try, you will get so much errors. And here something has broken. You get many errors, type error, and so on. To fix it, we got to define a new method that returns a newly created object. And this method should be named, because previously we created this instance method that could potentially have other name. I just named it because it is logical, and later we provide it inside function to register singleton. But here here we have to add method name with the name create, and inside this create method we are just creating a new empty object with the string that we want to provide. Now, if we try to run it, everything works as expected. So you can choose and select your logs. But you probably wondering if there is no memory leak because you like creating with the new and it's looking a little bit scary. The answer is no, because the QML engine will assume ownership and delete the object. So don't worry about it. Okay, and we have the last method of integrating is instantiable QML type. There is a way to register an instantiable QML, instantiable object type to QML, so you can just register this type and create how many objects you need inside QML. And it is very good method to integrate your C++ class with QML because it gives you so much flexibility. Okay, let's go to the editor, and for now Let's go back to the default constructor. So I remove QString pass from here and from there, and just make it as it was. And here this thing we can also comment. Also comment this one. Okay, and let's also comment the QML singleton macro, because it is not singleton anymore, but QML element, because we want to, as you remember, QML element registers it to the QML. So we don't want to remove it. And I will show you firstly the simplest case when like you have default constructor and this QML element, but we should add now our class to the CMake inside CMake configuration. So here we have a Qt add module, and you just need to make sure that you have it here. Probably it is already registered, but like make sure. Okay, and now if you go to the main QML, here after importing it, importing that module, you can create your objects. So for example, inside the window, before everything, like let's go to here, we can just create, for example, two objects, logs filter, and it will be 1 and 2. And we can also specify default values. So we make two instances with different IDs. Notice that we can provide default file path, but we can do it, for example, with filtered logs, because we don't have a setter here. But here we have setter, so we can do it. Now let's try to change every usage of logs filter to this logs filter one. It won't take much time because program is not really large. And here. And if we run our app, and as you see, everything works as expected. You can choose, you can select. Okay, fine. And I didn't show you this with the previous one, with this good with this second of the singleton methods. But here, if you write, for example, logs filter, this is what I talked about with the tooling friendliness or unfriendliness. That if you write this dot, you can see what you have inside, and it's really handy when you're developing your application. And if you want your class to have not the default constructor, for example, because here I go back with not providing pass, then you need to just create the second one, just the overload for it. And let's add it here and specify values. So there's no need to create something like here with this create or instance or something. You just create overload. So if we run it one more time, let's check if we don't have any errors. Everything works, and that's fine. And but if there is no if there is only not non-default constructor, if you don't have this base one, then you will get error from QML while trying to create an object. So be careful, and also always add a default constructor and your constructor that you need. And I think this is it. We covered all ways of integrating a C++ class into your QML. Now you can make your application that you need, some simple one. And don't forget to hit like and subscribe button. It is really helpful for me. And thanks for watching. When developing a Qt application, sometimes you want to display images, videos, GIFs, or change font to a special one. Today, as always, I will show you the most commonly used ways to do it. Let's start with the basics. The Qt resource system is a platform-independent mechanism for shipping files in an application. It means that because of the way Qt works, every time you have a certain icons, videos, or whatever to display in QML, you must add it to your application in some way. But what are those ways? The first method is to add a QRC file and register resources inside it. It is just the XML where you specify files to load. In the compilation stage, the resource compiler, or simply RCC, starts his job. RCC reads provided resources and generates a C++ source file that contains a tremendous array of bytes that represent the resources you want to load. And finally, you will be able to use registered files in QML by adding a special prefix before passed to it. I think the best way to understand it is to use it practically. We'll make a simple app to display the kind of user profile. There is profile images and links to social media accounts. You will see how to make some layout, how to display images, how to load fonts, because as you see there is special font, and how to make this simple app. I already created my QtQuick application, and by the way, full code will be in the GitHub repository. Let's quickly just remove the stuff that we don't need, and rename it to, I don't know, profile. Okay, and maybe make it 700 by 700. And let's make width a little bit more like this, and rename it to root. Just basic setup. And here there is my project that I created, and here I also added images to display and the random free font I want to use. I mean, you can download it. I will put link in the description to where I download those icons and this font. So I just added folder named assets and put it inside. Okay, now right click on your project, add new, and here you'll have in Qt resource file. Name it, for example, resources. Next, finish. And as you see, Qt Creator gives us a graphical interface, so we don't have to edit the XML directly. You can add prefixes to structure your assets, then add files to created prefixes. Let's make like icons. Where I will put my icons, then avatars, where I will put my avatar, my logo, and fonts, for example. And inside it I can hit add files and go to here assets and select what assets I need inside this prefix. Then it files my logo, and the same with the fonts. Here font. If you open resources QRC file with the text editor, you can see that it is just XML. And here we register our RCC in our RCC with some prefixes, some files. And you can also use some attributes, and you can read about it in documentation. It's not that hard. There are not so many of them. In order to use the resource compiler, you have to edit CMakeLists file. As see, we already have something inside our file explorer, these resources, but to load it later in QML, you also need to edit your CMakeList. First of all, we should enable auto RCC. It will initialize the resource compiler on all files, and the only thing left for us now is to add here. Here we have Qt add QML module. We already added it resources, because if it didn't add it automatically for you, then just add resources and the name of the file with the resources. When you build up, now let's build, it will take some time because the resource compiler embeds all files right into the executable, as I showed you before in the presentation. It embeds file and creates the tremendous bytes array. In the main QML file, I will make a row layout to divide two sides of the window. So first of all, we should import layouts module, then add this row layout that will divide. This will be like a container for those two sides of my window, as you saw on the presentation. And inside this row, we're gonna have two column layouts to represent those sides. And inside first side, it is a profile images. So here I just put width to this parent, this container divided by 2 to take the half of the window. And inside image, I align it to the right, so it like stands at the center. And the most interesting thing is here in the sources, in the source. By the way, to display images, we use the image item. Inside the source property, we specify a path to our file. Because we use resource compiler, we should add a QRC prefix. So Qt knows where to search for a particular file. And if you don't want to write this full path, you can just go to your resources here, and for example, click at this logo and copy your resource path to clipboard. Then go to main QML, and here just Ctrl-V, just paste it. But don't forget to add QRC prefix. And of course, you can change this prefix. You can read about it in documentation. And before we make the second site, let's add a custom item inside another file that will helps us display a social media logo. Name of it and make links to the external resources. Because as you remember, we're gonna have like 3 links looking pretty much the same way, just changing the link, the URL and name of it, and pass to the image. And to not repeat my code so many times, because it's gonna be so large QML file, let's create just new one. Not in the sources, sorry. Just click on your project, then in Qt, add the QML file, and here name it, for example, profile link or something. Finish. Here you have item. And first of all, you're gonna need to import layouts, because if you use layouts, use it use it everywhere. And here I make an entire item as a row layout because it will lay inside the column layout. So here I will make second column layout and my row layout's gonna lay inside, and to not mess anything up. And the image with the text should be near. So in the row layout, it is like stands on the one line, just near. And so, okay, properties are just fields inside my item that I'll be able to fill with some data. So from my main, I will be just able to provide some string in this case. For example, I can source, link, or label, or whatever, and you can make your properties. We will, in the next episode, we will discuss more in detailed way QML objects and how everything works, but for now it's simple. Okay. Next you have image, where I provide icon source in the source, and then put some width and width and height. Then in the text I just provide a label. name of it. As for now, it's not link, but I'll show you how to do it. Just not everything in 1 second. And here we create, as I said, new column layout. Okay, I copied from Word, so it is a little bit messy. Sorry. As I fixed everything, and as you see, I added column layout, put the same width as I specified before, and put 3 links inside. So I don't have to import anything, okay, because it is all QML files that those are registered in my CMake, so don't worry about it. And inside main, I just create 3 links where I specify icon source, as I said, okay, here, Instagram, as I showed you before, how to provide those URLs and how to copy them from the your resources file, your QRC file. Then I provide link. Of course, you can use your profiles. It is not really matter, and I provide names that will be displayed, I mean label. And if we run the application, let's try, let's save everything. As you see, everything seems nice and working, but text is not clickable, it is not links right now, so we can't reach the hyperlink we provide, and also we have to change the font, so to make it more interesting, you know. Okay, to load fonts, we go to here, to profile link, and we can use font loader. Okay, let's make it after the properties font loader item. Font loader item just allows us to load some icons, but if you have a lot of fonts, I recommend you to separate font logic into another file to not repeat the same logic again and again. But just specify what you need later. So you create one object with all fonts and just then specify what you need. But in this project we have some text only here, and it does not make sense to make separated separated classes, separated objects. So I load it directly here, and then we can go to the text and provide font name like this. And to make it like a link, we can provide a mouse area. We can add mouse area. So mouse area, as I remember from the previous episode, just manages the way our mouse moves and handles some events like on clicked, on enter, on exit. And I enable the hover, and when mouse entered my link, I change color to blue, and when it's exited, I change back to black. So okay, if you run the application, let's see if everything works. As you see, we have our font loaded because we provided path properly. And then we have links. We can go to my profiles or something, or your profiles, doesn't matter. Okay, you can also avoid creating QRC files and add in and register your resources directly in CMake list. So here you can just disable this auto RSS, then let's comment the resources, and what you can do also is just edit like this. So you just provide every resource that you want to load, all images, fonts, and etc. In this case, as I said, you can disable auto RSC because CMake doesn't have to process it, and then you can use your files without any prefixes and in QML. So for example, here you can put just facets, logo PNG, or let's go next here. I have icon source, let's comment it so it lay in my repository, and change it to just assets, sorry. assets Instagram PNG the same way we can do here. Let's put just assets YouTube PNG, and the same here, comment, and here assets medium PNG, and there is font left to us, so everything works. So go here, I will also comment it, and provide new path to my font. Okay, because here, as you remember, we use prefix, then path to our file. It is not very comfortable, of course, to add files one by one in CMake, because suppose you have many files and you don't want to take hundreds of lines in your CMake to load them, because it will be like pretty big CMake list just loading the resources that you need. But if you have a directory where all files should be loaded, for example, like I have this assets folder and every file inside should be loaded as a resource, then consider using something like this. You can, so what it does, and here also I'll comment it. Okay, sorry, I'll comment it and put new thing. Here we use the power of CMake and make a list. This will be a list of files recursively loaded in assets folder. So here, if you want, you can read the full documentation of the file function in CMake, in the CMake documentation, because I will now explain just the basics. So this argument will allow us to search files recursively in assets folder that we provide here. Then we specify the directory where we search and folder where we search. Like file asterisk means all files inside, and we put everything to assets files list. And here we don't need to write everything just line by line, and can just put resources and this list just as a variable. Of course, and if we run, I didn't change anything in my QML, and as you see, everything works. So you can go medium or something, everything works. And that is fine. This second method, by the way, where you load your resources directly in CMake, become available only in Qt6. And it is your choice really what to use, because QRC gives us more functionality. For example, you can make aliases to your files in QRC file. Maybe not here. Here you can put some alias and to not write this long thing, this assets local and whatever. Or you can also put different files for different locales. So you can choose what local user have, and depending on this, put different files inside. But as you see, registering in CMake is a little bit faster. So it is depending on your specific case and on your specific goal. And okay, I think this is it for today. I really thanks you for watching this video, and I hope you'll subscribe and hit the like button if it was helpful. In this video, we're gonna discuss one of the essential topics for the large QML projects. QML module provides versioning types and JavaScript resources in a type namespace. By the end of this video, we're gonna make this up with buttons module for items you see and styles module for managing colors and theme. Okay, let's add a little bit of theory before we jump into Creator and make our project with QML modules. So why do we want to use QML modules? The simplest answer is to separate logic. Most applications have many functionalities, and if you throw everything into the single directory, it will be such a mess. Also, modules allow us for type versioning. A module is defined by QML dir file. Each module has a type namespace, which is also an identifier. So in every directory, we're gonna have this QML dir file where we specify identifier of the module and the files we want to add inside it. So let's start making our application. First of all, I want to create the folder structure, because here you see we have default one, and it's not good for now. Okay, we will use a module for styles that will manage colors, and a module for buttons, where we will create a base button and inherit 3 different ones that will be used in main. And okay, so you can just right click and show in Explorer. I already opened it, my project directory in Explorer. So here, let's just create our directory simply, because it will be faster than clicking inside creator. Okay, the first is gonna be components, and inside components, let's add buttons module, and inside button module, let's, as I said, add first of all, it's gonna be base class for the base type for our button. It's gonna be custom button QML. Then I will just copy it 3 times and rename to, okay, primary one, the secondary, and danger. So if you worked with some CSS libraries, you understand what I mean by those buttons. Just this is base one, and here we just specify some colors, so we don't have to repeat every time we use it inside our code. And also in every directory where we have some, each directory with .qml files should contain QML dir. So create QML dir. For now, let's leave it empty, and we'll put something inside when we will add it to our solution. And also, when creating a QML document, be careful, because the name of it must begin with an uppercase letter. Okay, also, let's add the style module, and inside it, styles QML, where we will just predefine colors in our project, and QML dir. Okay, and now we have to add the created file structure to solution. So right click on your build, add existing directory, and here just select components and style module, because you want to add everything that is inside. Add, wait a little bit, and creator will add it to your CMake. Here, as you see, just one by one. And as you see, we have our files. And to avoid QML warnings about import path and problems with finding module, we can add an import path. So basically, let me specify it, and I will explain why I do it. So after loading, so before loading the QML file, we have to add import path. We can do it that way, but here I have tutorial 10 video, so I just changed to my project name. Okay, and why I do it? We specified the path in our project because that is where QML modules are laying. We will not write an absolute path to the files we want to import. I mean, later in main, for example, when we want to import module, we won't write absolute path. So instead, we'll just make use of module identifier. So QML should know where to search for it. And so we don't get any warnings when writing code, we gotta add this import path. I want to start with the style module because the second module will make use of that one. So let's go to the styles QML. I will just paste and explain you what is happening here. So some parts of the code can be new to you, so let me explain everything. The first line of code, we mark our item as a singleton. It works the same way as in the C++ singletons. So Qt create for us one consistent object, and we can get values from it without instantiating. So later I will just able to write something like styles and my color, background color, for example, without instantiating it, because it is singleton and it is already instantiated in one object. So we don't have some unique properties, we just make constants to use in our UI. Earlier, to make some basic items, we used the item type here. We make it like that. So as you see here, I use Qt object. The reason for this is that item is a basic type for something that should be displayed, but Qt object is kind of like the most basic type of in QML. It's like QObject in C++, that can be displayed, but can store values. So difference between that is just okay, let me write item can be displayed Qt object store values. And it's just kind of optimization. Inside it, we'll make an editable theme property and a lot of color properties that depend on the theme and can be changed because it is read only. So here, when we can change. We have dark theme or the bright one, and depending on that, colors gonna be changed. So I'll use for now just dark theme, but I wanted to show you how to do it in like real apps to not make some if statements. I mean, we make here the if statement, but one time, and it's inside one object. Okay, and inside QML dir, let's go here. I'll show you what we should write to add files and make module. We specify the name of the module and the items inside our module. Be careful because the name of the module, this one, should be, must be the same as folder name. Here we have style module. And unfortunately, that line of code on top, pragma singleton, is not enough for QML, and we have to also add the singleton flag here before our file. So here we specify the name, how we will call it later in when we make use of our module, then version, and then file that implementing it. Okay, and let's just right away test the newly created module. So here, let's add the background to the main window. So, because as you probably remember, we got this dark background on presentation. So let's use import style module and provide version 0.01. So okay, as I said to you before about this import pass warning. Okay, let's left it like this, just test if it works, and then we'll show you how to fix like the warning, because without this line, it just won't work. And we also got to fix our creator. Okay, and here I just add a rectangle to my window. So here I import styles module and specify the version I want to import. And remember that the name of the module must be the same as directory name. Just remember, and then I'm adding a rectangle that fills the full window and lays under all other items. Z is like a layer, because earlier we used only X and Y, but Qt supports three dimensions. And here for the color, as I wrote you before, just use styles, this name, and background color that is laying here inside. Okay, let's try to run it. Save QML there, and let's try to run it. Okay, we have some errors. Let me check what I done wrong. Okay, what has happened is that we created these QML files, buttons, and leave it empty. So we can do it. So for now, just rewrite what I have. I import QtQuick, and here I create item in custom button, and in the three left ones I import the same, but inherit this type from custom button. So I mean maybe not inherit, but make my item based on custom button. So integer button primary and secondary the same way. For now, just copy and paste it, and later I'll explain what is happening. So now if I run, I have my background, as you see, but we have this warning. And if you go to tools, QML reset code model, this not leaving us. So now we gotta use CMake, because as it is written here, for CMake projects, make sure QML import path visible in CMake cache txt. Okay, let's go to the CMake, and after adding our files, let's also add this QML import path. So here what we want to add is, let me explain those lines if you're not really experienced at this is a CMake user. Here I create list and append list name at QML dirs, and append to it CMake source dir. It's just the directory where all our files are laying. In this one, I mean. Okay, and then I set this QML import path the same as we got in my warning. Warning is already gone, but the same as it was in warning. And inside, I set to QML import path my list, because in CMake list, I mean, I pass it like a string, because in CMake lists are just like item 1, then item 2, separated like this. So it's just kind of string. And by specifying the string, we'll just binding the cache to this name. Or I don't know how to really call it, but you can just copy, or I don't know, maybe leave just Qt creator and your version. Or if you use it now for just testing purposes, you can write here what you want. Just how it will be assigned in cache, you know. And now if you save it and your project will rebuild, you see no errors, no warnings are here. And if warnings still there, then you can go to tools, as I showed you before, QML, and reset code model. It will force Qt creator to think one more time. Is it really warning? Is it really okay? I mean, process one more time your QML code. Okay, let's go to custom button, and I'll just paste and show what is happening here and implement it. Okay, let's start with this basement. If you use just property, like here, then one directional binding is made. And using this data in some item, for example, to set the text can cause the data to be out of date. In styles, we made a singleton object, so it is not really a way to make an alias. But here, as you see, I use alias. And alias keyword makes the binding bidirectional. It means that wherever we change the value property, it will be up to date. And here I specify where I want to pass it. So if we change this value on the run, then everything will be up to date. If you remember from the beginning of the video how this button is supposed to look, then notice that the border and the text color have the same color. And I done it just for the simplicity from one side, but from the other side it will make a little bit overhead right now. But it's okay. I'll show you how to do it. So the color of the border and text is the same, and when we hover on it on button, then the colors are changed to the background one. And unfortunately here, because okay, let's start from it, because here button height and width is like obvious, but why I specify it here and then specify it here, because rectangle is kind of like absolute item. I mean absolute, if you're familiar with CSS and HTML, it means that it can lay on other rectangle simply. And here, so it have some shape, and it is laying our layout in sensible way. I'll specify the width and height of inside item. Okay, then I have background color, and I pass it to rectangle color, then text color, and button and text. I pass it to text, to button text and text. Here text color I don't specify, I don't pass it nowhere, because now I will show you how to do this interesting binding with switching colors. And as I said, unfortunately, you can't pass two properties to the alias, but we can figure it out by adding some kind of middleware component between them. Because what I mean, In the perfect world, we could potentially like write something, button text color and specify the color, and we also want to add a border, so it will be perfect if I could write something like rectangle border and color. But we can't pass more than one parameter in our alias, so we got to make something with it. And now updated version. What I have done, as you see, I pass a text color to the new rectangle component that will be not visible, and then I used it inside my rectangle and text components. So here I add the text color. I have text color property, pass it to the shared rectangle, and then from the rectangle I use it in border color and text color. So okay, fine. To not getting back later also, I forgot, let's declare all buttons inside the QML dir document. I'll just copy and paste. Here, as you see, I added components and dot before the name of the folder, because here the name of the folder. Why I done that? Because, as I said before, the module identifier should be the same as a directory, and here we have first the components and then buttons module. And when we got this parent folder, we gotta add a dot between them. And as before, I specified the name, how I want to call it later, file and version. And buttons not are not singletons, so I use it without this flag as I done in styles. Okay, let's go to main and just quickly test our custom button that we created to make sure everything works correct. And now import components buttons module, the same as specified in QML dir. And here we can add our custom button, unknown component. Interesting. Let's try to run it. Oh, sorry, because here I misspelled. Oh, and now fine. We have this click me find button, and now I didn't use my styles. Here I just passed some static values because I will remove it later, and don't worry. We'll use buttons from danger button, primary, and so on. And notice also that we are passing anchors property, even though we didn't specify it in custom button file. It is possible because the root of button is item, and really custom button is kind of override of item. It's just like about because for someone it can be not obvious because I don't specify it anchors as a property, but I pass it. So how it works? That's how it works, because custom button is kind of override of item, and we just can pass it like this. Then specify width, height, color, text, color, and text. And as you see, I have color of the border and text set to white and background to red. But I pass only once this white. Okay, fine. If you run it, it looks okay, but we haven't implemented hovering and clicking logic yet. So let's do it. Go to custom and okay, how to fix this warning? I think we can just reset code model, and yes, it works okay. So go to custom button and here maybe after. Okay, let's make it before. Okay, I added this chunk of code. Just if you're interested, I mean, if you try to implement it yourself. And because I want to change text color and background color back and forth on hover, I defined two properties. They won't be changed, so they're not aliases, those ones. And I assign them to pass it once when component is loaded. So I create two properties, stored background color and stored text color, just to cache it, because later I will change those ones, so to switch. So here, when component is loaded, I store them. And then I also added signal to click, but wait a little bit for it. Let me explain firstly this, and then I add mouse area that helps us to add this hover and click events. Fill with parent, the parent is item, then enable hovering and write this logic. So when entered, I change the root background color, this, to stored text color, and text color to stored background color. So because those are aliases, it will change in all items where they are passed. And on exit, I change it back to the starting point, So text to the text, background to the background. I also added the click signal here, clicked, so that I can pass slot in main and can handle click event. Because here I just when click it, I call this signal, and later in main I can specify what will happen. So like this here in main. The signals and slots in QML work the same way as in C++, so if you don't understand it, then I highly recommend you to watch my video about signals and slots. So I passed this slot. Let's test how it works. Okay, when I hovered, nothing is working. Fine. Let's find out what is happening. Sorry, okay, I noticed here because I just copy and paste my code, mouse area should lay inside rectangle, of course. Because here I already created it, but I'm sorry. Just paste it to rectangle, inside rectangle, and now it will work. Here, as you see, I have this button. When we hover, it change colors back and forth, and when I click, clicked message is written because we pass slot here, and that's cool. What we have done already is a good basement, but if you have ever worked with the libraries like Bootstrap, there are always some ready-to-go buttons where you don't have to provide any colors like this, and just the text and optionally sizes. So I want to make 3 different types of button. I mean, I created it, but I want to implement it right now. So let's start with danger one. Here, then primary. I'll explain right now what is happening with them. And secondary. As you see, the implementation is pretty much the same. All I change is like because text color is the same, in every button, so I pass the same. I just import it from my module, then specify background color. In our case, in danger, it's gonna be some kind of red, a primary blue or something, and secondary yellow. So I just created from the custom button and specify properties I want to add. And see, here I specified more of them, but it is okay. It will work without, for example, like something like width. I will be able to specify sizes and text and slot later in main where I use it, because in those in those types it is just like middleware. I mean, I don't know here what I want to do in on click, so it is just reusable components, you know. So I'm doing this to avoid the copy on the same lines of code every time I want to instantiate the button, because most of the times applications have similar buttons and there is no sense to provide the same color every time instead of use this prepared classes. So let's use our new components in main. So here, but then I deleted the previous code with a custom button, add column with spacing and centering, and here I use first the primary button with width, height, text, and the slot on click, then secondary button, and then danger button. So if I run it, okay, it's interesting. Okay, let me see what I done so far. Okay, so I noticed one thing when I copy and paste my code, I messed it up and I deleted those lines. And as I said, you see this error, like if I don't edit, but I provide width and height to rectangle, that's what I see. Really, here buttons are laying on each other just. And if I edit, then you see I have my buttons just as in the beginning of the video. And if I click, I get my messages. So as you see, in that way we can create reusable QML modules. And that's really all I got today. So thanks you for watching and see you in the next episode. Most applications need some large data presentation. Earlier, we only displayed static data with simple components like a single text, buttons, etc. Today, we will dive into models and views in Qt, and I will show you how to display large data sets in your application. For example, views, tables, grids, and so on. The plan for today's video is to cover C++ models and the views in QtQuick. By the end of the video, we will make this list application with all CRUD operations. So we can create, read, update, and delete data from list. Model view is a class that contains the data and its structure. QML provides us with a couple of models like list model, table model, item selection model, etc. But most of the time you will create your own custom one in C++ using a QAbstract model or a class derived from it. So as you see, it's like quick presentation of from the Qt documentation how model and view work together. So model contains data inside it and structure, and the view is just for the rendering part. A view is a container for displaying collections of data. QtQuick gives us a set of standard views like list view, grid view, path view, table view, and tree view. They're all customizable, and most of the time you will use one of those standard views because they really fulfill your needs and you can customize them in all kinds of ways. And as you see here on this graphical representation, view renders, model manages data and some business logic. Let's take a look at those views in the example project. So I just created project, and let's create a new file, QML file. Let's name it list example, and it's QML file. Okay, I will paste the full example and explain what is happening here. And also we got to import QtQuick controls. Okay, as you see here, we created list view and provided the model. So I told you before about list view. It's class the type representing data, and the model is just where we store the data inside it. The model contains list elements, where each one of them has properties. But in the case of models, we call them roles. And you will see why I mention it when we will jump to C++. We also provide a delegate here. There is just a template object that will be displayed for every list element inside a delegate. Use name here, name and email roles inside the text to display data, and they are matching with those roles here in the email. So to summarize, we have list view. That is the type to display list. Just we specify some height. Also, all those views have spacing, just spacing between elements, so they not like together. They have some gap between. And then we provide model. That is just a list model. Later we will create this in C++, our custom one, but for now I just want to show you an example. Inside list model, we just create items like in just list. Each one of them contains roles, name and email, and later in the delegate is just template for each one of elements in list that will be created for each of those list elements. And we use name and email roles to display some data. Okay, I repeated it twice because first time it may be hard to understand just right away. Okay, now we can go to main, and I will create a column layout because later we will make a grid, buttons, and so on. And also I have to import QtQuick layouts because column layout is from the layouts module. Okay, we have our list with all the elements we provided. Let's run and see what we got. Here you see I have this list. And by the way, I didn't mention, but I think it's obvious, frame just adds border to our element, so you see the boundaries. I mean, you can replace it with item or whatever you like. Okay, we can customize it and add a header and a footer to this list. I also okay, let me paste my code. So we can specify here header. It will be just a rectangle with width the same as our list, with the height 30, background color, and some text that it is contacts list, just as you saw at the beginning of the episode on my presentation. And let's also add footer. By the way, you can just select it and hit Ctrl I, and it will fix all those tabs and spaces. Okay, I also pass footer positioning here, so the footer is always visible at the bottom, because you have different ways of presenting your of position your footer. You can read about it in documentation. It's just like it's overlay, or it's just at the end all the time, and like this, not some hard things. And I also provided z value in the footer, and it can be different. Just make sure it is bigger than in delegate. In delegate I didn't specify nothing, so 10 is okay. Maybe I can pass 5, for example, but it doesn't matter, just so it lays on top of the last element, on top of the last delegate. There are also so many properties you can provide to your view. For example, you can add remove animation, selection, highlighting, etc. You can just go to documentation and see, because there is a lot of those properties, and I just won't be able to show you each and every one of them. And it's not hard to specify. Like here, I just pass a rectangle, and it will work right now, I hope. Let's see. Here, as you see, I have my rectangle with text, and on the bottom just my thinner rectangle, its footer, and 3 elements inside that I created. Okay, now let's explore grid view. Grid view uses the same list model as here, but displays it in different way. So let's move out data to separate file. I will just create a new file with new QML and name it example dataset, just this list. And I'll extract from list example, pass it here, and fix spaces and tabs. Okay, and here I can just write example dataset, create it as a type. Let's check if it works with our list. So we can continue with grid. Yes, as you see, it works, and that's fine. Let's now, and in that way we can just avoid copying the same code over and over again. So let's create document for the grid and name it grid example. Okay, fine. And here, let me just copy and paste this code that I have. Example dataset. Fine. Here, just like before, I pass some width and height, then I pass model, the same list model with list elements, and then delegate. Here we use pretty much the same technique, but if the delegate doesn't have enough space horizontally, it goes on the next line. You're also able to specify cell widths, height, and other unique for grid properties. But now I only show you a quick example of usage because I want to make this example with list just more complicated with C++ and to not spend your time on showing just the controls that you can test on your own simply. So let's put it in main. Also great example. And let's see how it looks like. And you see, as I said you before, when it doesn't have enough space, it goes on the next line. So here. Here I just create text and the next text with the same rows as I done it before, and center it horizontally. And put it in columns so they stay vertically aligned. So you basically saw how to create a model with some rows and display it in a list or grid in your QML. But we have done it in QML, but the problem is that QML is not that flexible, and when you probably will want to integrate your application with the database or other sources, and then you will have certain problems. Now I will show you how to create a model in C++. Firstly, we will make only the displaying part, so QML can just get data from it and display it in views, and then we will implement create, update, and delete functionality. Before we start, let's discuss two very important classes we will use to create a model: QAbstractItem model and QAbstractList model. QAbstractItem model is an abstract class that defines the standard way components work with each other in model view architecture. If you don't remember from some basic C++ tutorials what is an abstract class, it is a class that can't be used directly. We must subclass an abstract class and create our new class by overriding some methods that are custom for each case. So we just have to override some methods because they don't really implement it. Okay, and QAbstractItemModel uses QModel_index for managing underlying data. QModel_index consists of row and column, so data is stored in a hierarchy of tables. But if you want a simple list, then it is just a table of rows or columns. So you just select your one dimension that you want to use, and it is not a problem. Every record inside the model can also have parent index. It is made for hierarchy. For example, views like File Explorer, like in File Explorer, where you have folder and parent, where you have folder as a parent and files as children. This class provides you so many methods you can implement, and they will be used by the view. I will later, when we will implement, I will show you how many methods you can possibly override, and you really can do whatever you want with it. But you don't have to always use QAbstractItemModel and implement everything on your own. There are common usages of this class, for example, a list. Qt provides us with the QAbstractListModel that is also abstract and also has to be subclassed. But as the name suggests, it is already a non-hierarchical sequence of elements. QAbstractListModel is a subclass from QAbstractItemModel, so it is just an improved version for specific needs. And remember that QAbstractListModel is not the only class that can be used for more specific cases. You also have, for example, QAbstractTableModel, QFileSystemModel, QStringListModel, etc. So when you create your own application, open documentation and see what meets your needs the best. Okay, so let's create our list model and implement the create, read, update, and delete functionality in it. Firstly, add a QObject. Here, C++ class, go to QObject to your project, and let's name it contacts model. Let's create it, finish. And here we have it, CMake is loading, and I will right away change the class we're inheriting. Here I want to include QAbstractListModel, and this I will say in a second what we'll do with it. Let's change the class we're inheriting to QAbstractListModel, and also change it here in constructor, so you won't have any bugs later, and you don't forget about it. Okay, and I also right away want to make this class QML element, so we can instantiate it in QML. If you're not familiar with QML element macro and C++ and QML integration, I strongly suggest you to watch my video about it, because I made a tremendous video that fully covers integration of C++ and QML. So in the source file we replace it, this class in the constructor, and now you can right click on the inherited class and go to refactor, inherit virtual functions of base class. Here you see the full list of methods we can override. The important thing is that you don't have to override every method. You need to do it only you need to do it with only the ones that you need for your purposes. So, for example, if you want to only displaying, then override only displaying classes and don't touch the others like for updating. And it works. It's like depending on what functionality you want to customly make in your list. So to start off and display some data, we need to implement row count. It's already selected as like the most basic one. Then data, so you can get some data from our model, and role names. Let's search for role names. Okay, I just wrote it here. Role names. I can here it is on the bottom of QAbstract item model. Okay, and override add virtual. You can just leave it as the default, so it will be okay. We can remove comments because we'll later add new methods, and it is not necessary for now. Okay, so you see you have those definitions for your methods you have to implement, and okay, we have to store name and the email. So let's also make a structure that will contain those fields, because I want to make a list with the same data as like here. Okay, here I make a structure with the name and email with the QString class, and I also defined the enum here. And wait a second, and when we will implement data and role names, I will explain the point of using it and what is happening here, what Qt user role, why we should define it. Okay, we store a list. So internally in model, we should store some data. In our case, it's the list, so we can just make it like here with the structure contact. And I also have to include vector. Okay, and we can either use one of the containers that Qt provides us, or we can use STL, like I done it here. I will use STL because Qt containers are pretty much legacy. One of the worst parts of Qt containers is that they do not support move semantics. With HTL, we can be sure that it uses the most efficient ways of working with data, and it's already it always up to date with all updates and so on. So I prefer to use vector here. Okay, we started in a private member of our class. Now let's go to the source file, and we can implement everything. But first of all, I want to add some mock data. If you like, wait a second, let me copy, and here I will paste my mock data. Here I just give some data to my vector, some mock data that we will test our application with this data, and I just pass it in a constructor with those braces, so it will initialize structure. It's like one of the ways to construct structure in C++. Okay, and if you don't know what is QString literal and why am I using it, then I strongly suggest you to watch my video about it. I explain it well when to use QString literal, when other classes related to string, and so on. And in the real world scenario, you'll most likely create a separate class to work with database and call some method from it in a container. But here we can just hard code some data to have an example. So if you remember from presentation, you have this like model and it's pointing also to the data. And this data can be like separated class where you call your API, database, or whatever. Okay, so now let's go and implement our method definition for the row count, for the data refactor, and then the definition, just to simplify what we are doing here. Okay, row count simply returns the number of elements the view has to display. I earlier said that QModel index represents row and column. In this case, method receives a parent index. We can use it in case we have a nested structure and want to give the size of the current node. I also add the QDebug to output some text in console, and just so you see when this method is really called by Qt, by list view. I also have to include it, I think. Include QDebug. Fine. I just write some data that notifying that row count is called, count is called, and return the size of my vector. Okay, role names. I will skip for now data. Okay, role names are an interesting one. We have to use a previously defined enum here. So let me copy and paste what is happening and explain you what is happening here. We have a hash table with the key of the enum and the value as the name of the property. Those names are going to be used inside QML. So like here, I use here name, email, and we define those strings with the roles. And here we specify it. So when you want to get a specific item in QML, you write a name of it. You write a name of property. But inside the C++ code, we can store it just as an integer, just as enum, to reduce the space that is used. The important thing to mention here is that Qt by default also have some roles. And I can show you by going to user role. Here you see we have some roles already. And because of that, our enum starts from user role. And then we continue this this list of enums because user role here is the last one. If we would normally leave it and start from 0, data won't be displayed because roles are conflicting with each other and just no data will be displayed. By the way, I don't use QString literal here because the qbyte array and it is similar to QString, but it is not the same thing. This structure is used to store both row bytes and traditional 8-bit strings. Okay, and then I just return this hash table with all roles and the name of roles defined, specified. Okay, we have a data method left for us. This last method to implement for displaying. This method receives an index of the record and the role that we should return. The role is presenting a the role is representing a property of a structure. We store the current record. So let me just paste the implementation, and you will see what I mean. Because and also QVariant is used to store reference to values where you don't know what type is lying inside. When you want to get the value, you should call one of the converting methods that will return stored value. So I don't know if it will be visible here, but if I write like this, you see you have so many methods like toChart, today, time, double, and so on, so on. So you can just store a lot of primitive types inside QVariant. Because data method returns some properties. The property that Qt is calling, that wants to get from us. And inside method, we are checking if index is valid, or more specifically, if the index is not going out of boundaries of our list. The thing is that Qt displays view so that it fetches only needed ones, only needed records, and then deletes them from the memory when the user doesn't see them. I will later make the list bigger, and you will see what I mean by looking at the console output. And I mean, sometimes Qt can provide not a valid ID, so we have to check it here. And I return false if something is not right. Then I just QDebug something just so you see when Qt is calling our method, and then with the help of switch statement, I check what Qt asks for and return an according data. So here I just get the item that Qt calls us. I get row. I can also use column, but when you make your list, you just have to use one of it, either row or column. In my case, I will use row, and I return name if the role is name here. If role is email role, I return email. If none of them, then I just return false. Okay. And now let's create an instance of the model in main QML. It is quick and easy. And okay, so we can just write here contacts model unknown component, but if I okay, let's leave it as it is, because sometimes Qt okay, because I didn't import it. I have to import here when I use QML element. I also have to import this URI of my project and specify version. And now I will have it. I certainly will have it, okay? Let's move on quickly and also pass model in the list example, and we can also do it to the grid example just so you see that this class can be used in both cases. Let's delete from here model because we pass it from the main, and there is no sense to use it. And let's run application and check if it will finally work. Yes, as you see, it's just a problem of Qt Creator. And I made those QDebug prints, and as you see, if we run the application, first of all, everything works. Data is displayed with the help of C++ model. But let's quickly, maybe let's comment also grid just to see what what is written here to not get anything duplicated. Okay, so take a look. As you see, row count is called multiple times by the engine, and it is okay because we only return the size, and it's like so quick operation. Role names is called only once, and Qt stores that hash table in memory. Then data is called, let's count 1, 2, 3, 4, 5, no, sorry, 3. It's either wait, why it is interesting because it calls it 5 times. Okay, let's Control F. Oh, okay, six times. I don't know. Maybe I'm just blind. Okay, so it is calling data method 6 times, and this is exact number of data properties we have, because there are 3 elements, and each have each of the element has 2 fields here, name and email, and we have 3 like instances of contact. So we get data called 6 times. Just so you see how it renders when you have so many items, let's copy records in the constructor so many times and see the output. I will just copy and paste so many times the same record. So let's see what we have in our console in application output. Okay, so first it loads some data, and now as I scroll, it will load more data, because now not all data is loaded. Loaded is only data that Qt needs to show. And now if I I have some bug with list, but it don't really matter. Probably I forgot to add some parameter. And if you see, new calls to row count and data are generated here as I scroll. As you see, Qt is calling data and frees memory from the first elements. So Qt just used that way of displaying. That Qt loads only records that should be displayed at this exact moment. We have our displaying functionality, so now it is time to create new items in a list. Earlier we needed to override the data method, this one. Let me also hide the output. Earlier we needed to override data method from the QObject item model to display the data. When it comes to insertion, QAbstract list QAbstract item model has base methods, but you don't really have to override them. So you have this insert rows and insert columns, but it is not like required to override them. You can create just a QInvocable method that receives whatever parameter you want and returns whatever value you want, but to get data updated in the GUI, you must call 2 specific functions from the QAbstract item model. Those are called begin insert rows and end insert rows. I will show you now what are they and how to use them. And you should call them at the beginning and the end of insertion. And the same applies to columns. because here you also have insert columns, but in the list view it only makes sense to change the number of rows. Okay, so even though I don't have to override a base method, I will do it, and I will also create my own method that will just call a base one with certain parameters to make the job easier in QML. So I just want to show you all ways to do it. Let's move it to all our methods, delete these comments. So here we have insert rows, and I will also create method that will be called from, that will be like manually called from QML. I will make this QInvocable. If you don't know what is QInvocable, go to the C++ with QML integration video, and let's implement them. So refactor, a definition as always. Here, this, sorry, here the same. Okay. Insert rows method returns a boolean value. And it returns it depending on the success of adding a new item. So if something is not right, something is failed, then false. It's everything is okay, then true, simply. And let me paste my implementation. Here we have it. Okay. On the first line, I'm making sure that the row and count are not negative. So here it's if it is less than 0 or count is less than 0, I return false, and everywhere I use OR. Also, I make sure that the row where I have to insert new items is not bigger than vector size. I call here row count, but you could also call just m items size. Doesn't really matter. And I check it because otherwise I can get some kind of gap in the data. So I can have like a list. Let's show it just with digits on like this list, and I should insert from like to 6 index, 6 row, and count 2. So I will have, okay, it is index 3, so I have like this gap. And to avoid it, I check it and return false if something like this is passed. After validation, I call begin insert rows method, where we have that method from QAbstractItem model, as you see here, and I pass a parent index that always will be empty in our case because we don't have any sub-element system. Then row index where I start, and the row index where I finish. And here I make some kind of calculations. So I give a row plus count because there is count of elements we will insert, because method is called insert rows, like many, and -1 because the list has 0 based indexing, and it also takes the last element into account. The actual insertion is probably the most understandable part of everything here for you, because I just make loop and insert a new empty contact instances to the vector. So here just call begin plus index where I want to insert. Just call in a standard method from STL. And after all insertions, I call and insert rows to notify Qt that view can be changed. So when we call it, the visual representation will be changed in some way, and I like update it. Okay, so here in the next method, append empty row is just adding a new item to the end using a previously defined method. I want to use all the power of insert rows and insert a lot of items at once, but I wanted to show you how to implement it. Yes, maybe you wanted. Okay, and here I call row counts, and every time I provide some parameters. Maybe we can just make here default value to make our job easier and to not call it every time. Okay, fine. Now let's add an add button in our QML. It will just call this append the empty row method on click, nothing more. So let's go to the main. We can delete this grid and add button. Here also import QtQuick controls, because that is where button is laying. And on clicked, we just call context data append empty row. Let's start. Let's run and check if it works fine. Okay, let's add something, and we have our empty contact. We can add more and more. Okay, great. And now it comes to the most, I think, interesting part, updating data. Let's go to our class. So parent class QAbstract item model already has a method for changing data. We just have to override it. So it called set data here. Let's override, okay. And let's move it to our methods and add definition in source file. Similarly to the insertion, we have to return Boolean value that shows if an operation was successful. Okay, the method receives an index of the element you have to modify. In our case, we will only use a row, even though, as you already know, QModel list contains row and column. A value with the type QVariant that will be converted to a specific type depending on the role. That is a third parameter. So here you have my implementation. So firstly, I validate the index and create a reference to the item that should be modified. With the help of switch statement, I check what role should be modified, and if it is just some random int in the default case, then I just return false. As you see, I call value to string here and there, but the QVariant can, as I showed you before, QVariant can be converted to all kinds of primitive data types. So you can store in your structures integers, all kinds of numbers, dates, and so on, and maybe some arrays. Okay, and finally, I not return anything like in create, like in data, sorry, like in data, because here I just return data that is requested. Here I modify data, then break this switch statement, and after that, finally, to notify Qt about data modification, I emit the data changed signal with the current index and role. Here I was index and index because if you take a look inside, it comes from the Q item model, and it also can work for the tables. So we have a top left and bottom right index we should pass, and the rows that was changed. In our case, only one role was changed, so I just create this Q list in this way with the initialization list, initializer list. Okay, and the QML part will be a little bit harder than before. It's not just adding a button now, because I want to replace the text item with the text field when a user clicks on a text, so he can edit it. So you will see now what I mean by that. It's just I found it like cool functionality. So let's add. Okay, for now, don't add. Take a look here, because I will do it inside my delegate, and I will have to separate the text into three parts. First, it's like part with the name text that will be sometimes replaced with text field, and sometimes it's just text. Then this column sign, and then email. So it will be such a mess if I make everything in one document. So let me make and this elements with name and email will be the same, pretty much the same implementation. So to not repeat the code, let me create a new document for it. And let's name it editable text. Here, let me pass some starting things. Here, I specify a required property, which is a field. The field that the item should work with. I add the text and text field that is coming from controls, and I put everything in row layout so it lays horizontally. Okay, and here I will switch visibility of those two items depending on if user clicks on it or no, if it's empty or not. And okay, the initial visibility is defined by whatever field is empty or no. So if it is empty, then I show text field and user have to write something inside. If it is if it have something inside, then user see text with this field. Okay. And to give the ability to click and edit, let's add a mouse over and slot in the text field. So let me show you how I done it. So here I just provide mouse area, and when I click it, I fill it with my name text, of course. And when I click on it, then name text becomes invisible, and edit field becomes visible, so user can write something, modify something. And when the user already modified something and want to like change it inside our model, there is that event called on editing finished, so either user present or something. Then I assign this text from the text field to the field and change visibility one more time. And now when the input, when the field is empty, the text field is always shown. And set data method that we implemented earlier here, set data, will be called when is being called when I assign a field to the text input. So because here field I won't pass just some string, I will just pass this role from the model. Let me show you. Let's go to the list example, and you will see what I mean by that. So here I kind of rewrite this delegate, and okay, and I have to import QtQuick layouts. Maybe yes. Okay, so here I changed this delegate, rewrite it slightly. So here I have row layout, so everything lays horizontally. For now, it not really makes sense, but later I will add deletion functionality and I will add button here. And inside I make another row layout for everything also lays horizontally. And I make two editable text items. First with field name and second with email. And between them I make that column. And let's run it and see how it works. Let's add, and you see I can add something. If a field is empty, then it won't be changed to the just text because of where editable text, because of this if statement. But if I write something, don't know, email, doesn't matter, and press enter, then I have it, and I can modify it, change it. So in here also I can modify, change it. I can here modify, just you see how it works. I mean, I can modify and change the values. I can click, and it is changed. Okay, fine. The way of deleting data is pretty similar to insertion, and we also can but don't have to define the remove rows method and call specific methods before and after the deletion. So it is pretty similar to insertion. Let's quickly do that and finish with our crude functionality. So go ahead, let's add implementation for remove rows. Move it a little bit higher. And I'll also, just as with the insertion, I'll add my method that will be just easier way to use this one. And parameters are similar to the, I mean, similar, the same as in insert rows method. So it is obvious that we just have to remove the count items starting from the row index. Let's add implementation as a definition and implement those functions. Yes, those methods. So here, I don't know if you see, because it's pretty long line. Make it like this. Okay, so the implementation is pretty similar to the insertion, but as previous, I validate indexes that were given to me, so nothing will crash with my STL when I call this arrays method. And just accept, and everything is the same except the thing that I call begin remove rows and end remove rows with the same indexes, and I call arrays instead of making some loop, because it still provides us method where we can just remove from this to this, where we can provide the starting point and end point, and we can erase everything from a vector. And inside the remove add, I can just write like this. I mean, I just call this remove rows method, starting with row that is provided to us, that I will provide from a QML, only one element, and empty Q model index, because we don't have any parents in our case. Let's go to the list example. And here inside the delegate, as I said you before, after row layout, I will add a button that will just call the remove add method and remove corresponding record. So here, except this stuff that you know, like passing text as minus, here I get this list because I have ID list in list view. Then I go to the model that is provided from main. Here we provide model, and then call remove add method, providing model row. Model row is just model. In our case, It's just the record. It is just a thing that is available to the delegate. We can get the record we're working with right now with the help of model, and I get row from it. The same, I can also get column if I want. So okay, let's run and see if it works. And we can remove, add, edit something, create whatever you want. Remove, add, remove. Maybe let's add many items, and just this way. And that is how we done CRUD operations in Qt, in QtQuick with C++ model. I hope you enjoyed. I hope you, first of all, learned something from this episode because it was pretty long. I'm pretty tired right now, and also feel free to write your feedback in the comments. And see you later.